Okay, 3, 2, 1. Hello world! Hi! This morning starts with a pretty new thing for me and really unexpected. Last Wednesday I had two new watchers which I interacted with. It was really fun and they posed even very interesting questions. And one of them, Deity, which is also now part of the community in Discord, cheered me up with 100 bits. Thanks a lot. I don't even know what it means. I'm sorry for that, but I think that you're supporting me, and I think that you spent some money for that. So thanks a lot. I have no idea what is this, but I was looking at purchase bits, and apparently 100 bits is €1.54. So you spend €1.54 to cheer me up. That's awesome. Thanks a lot. You're my first, I don't know, how's it called? Donor? Bitter? Cheerer? I have no idea. It's a way to support your streamers by cheering with bits. Cheering elevates your voice in chat with animated emotes, etc, etc. Thanks a lot. I don't know what to say. So, last week we finished finally this topic about data types, and we covered especially array methods, which is a topic that, as you understood, I really care about. And we also saw some destructuring, some spread operator, as it's called. And we also had a look at dates and times, but we also said, yeah, dates and times are fine, but usually it's better to use a library to manage dates and times. We also said that Moment.js is probably now outdated by the same developers of Moment.js, who now suggest to use other libraries such as Day.js, Date.fns, or I don't even remember the other names. And last Wednesday, we did also a few exercises about array methods. So I hope that this topic is now covered. Last Saturday, we also had a taste on how to build a sort of real life world application with just JavaScript, by not knowing everything that we were supposed to know, but knowing how to look on the internet for the information that we are lacking. Oh, I even forgot to open Visual Studio Code. So let's hope a few seconds, hopefully, if it wants to. Yep, it opens. And probably also have to remove some of the projects that I'm doing for some clients. You didn't see anything, right? You haven't seen anything. Hi, Angelo. Good morning. I'm going to do the usual stuff, increasing the font size, and also create a new folder called 21. Today we're going to do a lot of things, probably. I don't even know. Let's see what we are able to do. I would probably call this, I don't know, functions, because we're starting with functions, and then we will see. But don't worry, it's not the usual stuff about functions. We will see some cool stuff, some new stuff, or maybe rehearse some old stuff that I just only mentioned. Good morning, Sal. Good morning, Angelo. Nice to see you here. So, I hope that you were here from the beginning, from 4 minutes ago. Otherwise, it means that you were watching the advertisements. I hope it was not 4 minutes of advertisements. So we're going to have a look at recursion again, because, well, recursion means recurring again and again and again, so why not? But we are going to have a deeper look on the call stack. The call stack is something that Bobby was asking me for many lessons, and finally I decided to give you some information about call stacks. Also because yesterday I stumbled upon a very cool YouTube video that I really recommend you to watch too, at least at the end of this lesson. And it's all about recursion, it's about asynchronous calls, and it's about the call stack. So we will have a look at a cool way to visualize the call stack and how things work. Hi Tiago, good morning. So, About recursion, you probably remember already what recursion is. It just means that you have a function that is able to call itself, or it's a function that is able to call another function that is able to call the original function. So, for example, if I say function call me, and this function inside of it invokes call me, this is a recursive function, and this is a function that explodes. Please don't invoke this function. Why is that? Well, because call me invokes call me, and call me invokes call me, and call me invokes call me. So this will be an infinite loop of calls. Not completely infinite. As you will see, the calls are stacked inside of a structure called a call stack. And you know what a stack is because it's a collection of elements piled up one on top of the other. And you can push things on the stack, which means you can place things on top of the stack. And you can also pop things from the stack, which means that you can remove the topmost element of that stack. So the stack is an important data structure. We already saw that arrays can be used as stacks. In fact, we have methods like push and pop, which allow you to insert and remove elements from the top of the stack. And there is also this concept of a call stack, which is a stack that is not managed by you. It is managed by the environment. It's managed by the browser. It's managed by Node.js. And it puts on top of the stack every function invocation before starting to invoke them for real. So if I do call me will invoke call me, and call me will be placed on top of the stack. But then call me also calls call me, so that thing will be invoked on, will be placed on top of the stack, etc., etc. What you want usually is to have some condition for which you can stop calling indefinitely. So, for example, usually we have a function that has, for example, I will say a number, okay, and you can maybe print that number if you want to. And then maybe do a call me of number -1. I'm just improvising. There's no real meaning for that. But then you also want to say something like, hey, but if the number is 1, for example, just stop there. I don't want to do anything else. Or I can do exactly the opposite. If the number is greater than 1, wait a second. Okay, if the number is greater than 1, then continue calling the functions. Otherwise, I'm stopping there. So as you can see, just the fact of having this number parameter and the fact that the number parameter can be changed in every invocation of the function, and the fact that there is an if which tells if I really want to continue with this invocation loop or not, this makes the recursive function not infinite. It will stop at a certain point. Let's see if it really works. I'll say call me 5. Okay, yeah, apparently it works. So it logs 5. Then 5 is still greater than 1, so it invokes call me on 5 minus 1, which is 4. And then it will be doing this for 3, for 2, for 1. As soon as the number is 1, it is printed, but then the number is not greater than 1 anymore, so it's not calling anything else anymore. So as you can see, it's very similar to a loop. And in fact, any recursive function can be rewritten as just a loop. You're not forced to use recursive functions. But recursive functions sometimes are easier to read, easier to write. Sometimes maybe they can even be more performant than loops, but sometimes not. Maybe loops are more performant than recursive functions. And sometimes you just appreciate them more. So let's have a look at this kind of visualization tool that I discovered just yesterday for you. This visualization tool is called Loop, but it's Loop like L-O-U-P-E. And the website is latentflip.com/loop. I'm going to copy this in the chat so it will be easier for you guys to get it. And as you can see, the website starts with a pop-up, a modal, as some people say, which refers to this YouTube videos that I was referring to. This guy is a very smart guy, and he did this video in which he explains how the JavaScript event loop works, and he explains it very well. At first, it's almost trivial what he says, but then he shows this tool in which he shows exactly what happens with asynchronous calls, and things get much more interesting. So I will try to use this one too. I'm going to close the modal, I'm going to increase the font size, and I'm going to try and do something with this interface. So I'm going to copy this function that I have here. And as you can see here on the top right, it's the editor. You can write whatever JavaScript code you want. Here below, it's the rendered JavaScript, which does not reflect at all what I have here, because I just have a recursive function, and here we've got two buttons, edit and click me, which makes no sense. Then here we've got the call stack. So this is the representation of the stack. It's a pile that has nothing, but we will see that every second we will see things being piled up. Here we've got web APIs, which will not be populated at first, and here we have the callback queue, which is not populated at first. So let's focus for now only on this part of the editor and on the call stack. Something happens every 1 second, and I hope you will be able to follow, but if you're not, I will just give you a spoiler alert. What happens is that we will see the call me function being placed in the call stack, and then the function will call itself. So you will see another invocation of call me in the call stack, and you will see probably 5 of those invocations all stacked up until I run out of calls. So all of the calls are then processed one by one, popping them out of the stack. Let's see if it works. I save and run. Okay, see nothing happening because I'm not invoking call me. So I have to also invoke call me given, for example, 5. Otherwise, nothing will happen. Save and run again. Okay, call me 5, console log num. Call me 5, num is greater than 1, num 1. You see that all these invocations of call me are stacked until I reach the number of 5 invocations, I think. Let's see what happens now that we have no room left. Okay, it goes up, up, up. And at a certain point, the number will be exactly 1. So you see all the invocations being removed one by one from the stack. Let's go with a simpler example, okay? I think that's already too complicated, maybe. Let's do just a function sum of a and b. This function returns the sum of a plus b. And if I invoke this sum on 2 and 3, let's see what happens. Sum of 2 and 3, it does a plus b. A plus b is processed and removed from the stack. Then also sum of a and b is processed and removed from the stack. And that's it. So this was really, really, really easy. And we can do other things like, let's see, with the square. Square of a number will return a squared. Okay, so now I've got this other invocation. Probably this interpreter here doesn't really understand the double asterisk. So you know what? I'm going to use a times a, which is more fail-safe. The JavaScript that you see here is processed by a tool called Esprima. And we don't need to care what this tool is, but apparently it's a tool that is able to look at some JavaScript code and interpret it and give you the result. So this Esprima, or at least this version of Esprima, is not able to understand some of the constructs that are newer on the language. So let's stick with the classic language. So let's try to do something like sum of square of 2 and of square of 3. Okay, I'm invoking functions inside of functions. Let's see what happens now. So sum of square 2, it processes first square of 2, then it processes square of 3, And then once we've got the squares, it will process a plus b. And now we've got the results, okay? So this is how the call stack works. And it works in every programming language like this. It's a stack. And if you create an infinite recursive function, the stack will be bloated by invocations and invocations and invocations until you reach the so-called stack overflow. At least this is how it's called in certain languages, such as probably Java. In JavaScript, we don't have stack overflow, but it's something really, really similar. Let's create an infinite recursive function, such as, I don't know, this one here. Let's just, oops, wait a second, I got it wrong. It's so difficult to write functions in here. I have to press Shift Enter in order to not evaluate this function, but just to go to a new line. Okay, so this is an infinite recursive function because call me just calls itself indefinitely. And if I invoke call me, hopefully my computer will not explode because JavaScript will say, hey, you reached a huge amount of invocations. There's probably something wrong. Yep, maximum call stack size exceeded. So this is another term to say stack overflow. The stack can host at most a certain number of invocations, and probably the number of invocation exploded to a huge number which exceeded the stack size. So JavaScript said, hey, instead of just blocking everything and making so that your function becomes a virus, let's just stop it here. Maybe there's something wrong in your code. So thanks a lot, JavaScript, for not breaking my computer. Okay, so this is recursion. It's really nothing more than this. With recursion, you can do multiple things, of course. And a few things, we already saw them. For example, I asked you to create a factorial function. And you know what? Maybe we can try to do it right now. So Factorial Js is a function that I can create in two ways, either with just looping or with recursion. And we can see the difference between the two. There's not much difference. And this is part of an exercise that I gave to Bobby a few lessons ago because it was a very difficult task and he wants to be challenged. So now we can start maybe facing this problem step by step all together. Bobby instead had to try it by himself without knowing anything about the call stack or recursion, etc. He had to learn these things by himself. So, factorial function, I will say that we can create an iterative factorial, or yeah. And then this is one function. And then we can create another function which will be called recursive factorial. Iterative factorial just means that we're going to iterate over some index. So we're going to just loop. If you want to call it looping factorial, that's fine. I usually call it iterative. Okay, what is a factorial? A factorial is a mathematical concept which is pretty easy to grasp. It is usually written with just an exclamation mark. So, for example, 5 exclamation doesn't mean that you're shouting 5. It means that this is 5 factorial. And 5 factorial means that it's 5 times 4 times 3 times 2 times, if you want to, 1, which doesn't make any difference at all, because everything times 1 is the same concept, the same number. So 5 factorial is itself times the number minus 1 times the number minus 2 times the number minus 3, etc., until you reach 1. And this is enough to create the iterative factorial. In fact, the iterative factorial given a number is, let's try and do it with a loop. Maybe we can do it with the usual index loop. So for let I is equal to blah, blah, blah. We can loop from 5 to 1, or we can loop from 1 to 5. It's exactly the same thing, of course. If I want to be strict and just model in JavaScript whatever I wrote here, I should probably start with number and then go down instead of starting with 1 and go up. But it's exactly the same thing, of course. And you can try as an exercise to instead reverse this loop and see that it just works the same. So let I is equal to num. Then I will stop as soon as the number reaches 1. Included, I want to multiply by 1. I could also avoid multiplying by 1 because it's stupid. It doesn't make any sense, but why not? So I would say that I will stop as soon as I is greater than or equal 1. And then I minus minus because I want to have this counter go down, not up, right? From 5 to 4 to 3 to 2 to 1 included, and then I will stop. And now the usual stuff is like accumulating a value, right? We usually accumulate a value when we sum. This time we have to accumulate a value when doing multiplications. So we can do something like let factorial is equal to, yeah, but what is the initial value of factorial? Can we start with 0? Probably not, because if I now say that the current value of factorial is itself times I, well, this is 0 times 5 times 1 times 4 times 3 times 2 times 1. Doesn't work really that way. I should probably say that the initial value of the factorial should be something else, something that is feasible. So now I'm starting to go toward a very strange path. I could say that the factorial starts with the first number, 5, and then I will iterate over all the other values. So I start with 5, and then I multiply it by 4, by 3, by 2, by 1. And this is fine, yes. I can say that the factorial starts with the current number, but then I should start with number minus 1, because I already have 5, and so I have to go with 4. I have to multiply the factorial times 4, and then the factorial is now times 5 times 4. So the number, the index decreases and becomes 3. So it will be 5 plus times 4 times 3, etc., until I reach 1. And in that case, I will return the factorial, and hopefully it should work, probably. I don't really know. But you know what? I can try it, and maybe I can try it on loop if it works. Unfortunately, I don't seem to be able to see the result actually here. Maybe there is a way to see the result. Maybe I should do an alert. Maybe an alert works. Alert factorial of 5. Let's see if this works. Okay, factorial 5. And it stopped here. It stopped here probably because it doesn't understand what alert is. Maybe I can do a console log. Still no can do. So I'm not sure this works in this context. Okay, then I'm going to just use the usual, or maybe the function has a different name. Oh yeah, of course. Sorry. Thanks a lot for telling me. Hi, Bobby. Finally, I see you. Okay, this works. Thanks a lot. So it's doing all these invocations, and the call stack is not increasing. The call stack is always 2 to 3. And finally, I've got my results. And oh, loop is telling me here what happens. Alert is not defined, so I couldn't use alert. And factorial was not defined. But then I was able to use the console log of Iterative Factorial, and this is what is happening. 5, 4, 3, 2, 1. And then I have no idea what this is. So this is just this is not the console log. This is the loop telling me what is the current results. I still don't see the log of this factorial. So I'm going to avoid using this factorial right now here in loop, and I'm going to do it on the browser. So this is my iterative factorial. I hope it works. If I do iterative factorial, I will say iterative factorial 5, and it gives me 120, which is correct. Because if I say 5 times 4, it's 20, times 3, it's 60. times 2, it's 120, and of course times 1, it's the same, 120. So yeah, the iterative factorial function works. I could also write it in a different way, maybe using function array methods. Shall we try? It would be the same. It would be still an iterative factorial, but with iterative array methods, I could iterate over an array. The problem here is that I don't have an array. I just have a number. So when using array methods, I have to transform this number into an array of all the numbers and then multiply them together. I think it's not a good thing to try with array methods. I think we can stay like this. So iterative factorial, if I say iterative factorial of 5, this is giving me 120. Yay! I console log this just to make sure that this works. If it gives me true, then it works. And then we can try to solve this as a recursive function. Why a recursive function? Well, because we can also think about the factorial function as a different kind of thing. 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1. But what is this 4 times 3 times 2 times 1? Well, this is 4 factorial. So 5 factorial is 5 times 4 factorial. And 4 factorial, for the record, is 4 times 3 factorial. And if you want to know what 3 factorial is 3 times 2 factorial. And about 2 factorial, well, 2 factorial is equal to 2 times 1 factorial. And this is where things change a little bit. 1 factorial is equal to itself. This is our base step. This is our stopping condition. If it wasn't for this condition here, we would do this indefinitely. This would be an infinite loop of invocations. But this guarantees that as soon as I reach 1, I can stop there because I'm not calling again and again and again another recursive factorial function. Okay? So, keeping in mind this thing here, the recursive factorial function can be written in a slightly different way. We take care at first of the base step. So, if the number that I receive is 1, then I return the number as it is, because there's nothing else to do. So, if number is equal to 1, then I will just return 1, because the factorial of 1 is a special case that doesn't do any calculations. It just returns 1, or I can just return the number itself, because the number is 1, okay? In any other case, I'm going to do something else. What am I going to do? Well, I'm just going to represent in code, in JavaScript, whatever is each one of these lines. I see that the factorial of a number is the number itself times the factorial of the number minus 1. And this is exactly what I can write. Return the number itself times the recursive factorial of the number minus 1. And that's it. This is how you create the factorial function recursively. As you can see, it's very clean and it's very neat compared to this index thing in which we had to define the initial value of the factorial. We had to tweak a little bit the for loop. We had to do all this stuff, all these calculations. Here, the calculation is almost implicit. You just say that the current factorial is the number times the factorial of the previous number. Ooh, what is this? Oh, it shows me, the comments that I wrote here. And the problem is solved by itself. We can try and see if the recursive factorial of 5 gives me 120, because it must give me the same results. And I can try to do this on Node.js, for example. So where are we now? We are in 21 JS functions. Yep, and I do node factorial, and it gives me true and true. Why true and true? Because the first one, the iterative factorial, gave me 120, and the second one gave me 122. So they gave me exactly the same results. But on loop, let's see what if there is any difference. So let's go back to this loop thing, and I'm going to paste this stuff. I cannot seem to be able to see all of this. So I'm going to remove this 120, which is not really that interesting now. And here I don't see the 120 probably, but I will see that the call stack will increment itself. We will see items pushed on the call stack and then processed one by one. Let's see, go. Okay. So as you can see, the stack is increasing now. This time it is increasing until it reaches a place in which we cannot even see what's happening. But at a certain point, the number will be 1. And so the call stack, we reach the end of the call stack. And finally, all these invocations can be processed one by one. And the call stack is empty again. Okay? So this is how the call stack works. I hope it's not really that difficult. I think that you already had some sort of grasp of this concept, and now you are able to visualize it. You visualize it better thanks to Loop, this awesome tool. Okay, this that you can see here is usually called a flow chart. It's a chart that shows you the flow of information. So here they are creating a power function that is recursive, because why not? You can also create a recursive power function. What is the power of a number? The power of a number is equal to the number, we have to say which is the power. So let's say n to the m, okay? N to the m means n times n times n, let's say m times, okay? So you just need to loop m times and multiply n by itself all these times. It's very similar to the factorial. The only difference here is that the factorial multiplies the number times the factorial of the previous number, of the num minus 1. And here instead we are multiplying the number by itself multiple times. Yes, the power can be defined as multiplying the number by itself m times, and this would be the iterative way. But there's also another way which says that the power of n times m is equal to n times the power of n to the m minus 1. Of course, the power of 1, well, the power of n to the power of 1 is just n itself. So there must be a special case that says that power of n to the power of 1 is just n itself. And this is our base step. This is what makes our recursion stop at a certain point, because we're not invoking the power function anymore at this stage. Okay, so you can try yourself writing your own power function, and I think it's pretty easy, especially if you understood how to build the iterative and the recursive factorial. This is probably even slightly easier, and you also have the same exact code in the tutorials, so you can have a look at it by yourself. And the flowchart shows you the graphical representation of how this code works. You start with a situation, and then this rhombus is usually posing a question. Is n equal to 1? This is an if-else scenario. So if true, then the condition is true, then this is the if body, and this is the else body. Which does something that is recursively calling the same function again and again and again until some condition is reached, and at the end you will give the result itself. So here you can see that all the execution is just exploded and very well introduced to you. but it's pretty much the same thing that I did. The execution context and stack, we already saw this. We don't really care about this concept about the context, but it's really, really similar to what we saw. The context is what we see in the call stack. And I think that we're done with recursion. Yeah. Okay, recursive structures. This is interesting. Not really that interesting, but it is interesting, especially if you want to learn something about algorithms and data structures. So when you're dealing with low-level languages, such as, for example, C, probably not with C++. Maybe with C++ you have libraries that get to your that help you a little more. But low-level languages do not have the concept of a stack or of a queue or of a list. They just have arrays. And in C, arrays are just pointers, which is a very low-level concept that luckily, nowadays, we don't need to know if we want to build web applications, because we're using higher level languages that abstract the concept of pointers and replace this concept as just references, right? References to objects, references to arrays, etc., etc. So one of the structures that you could stumble upon when studying algorithms and data structures is the concept of a linked list. A linked list is a list that is created by creating one object, and the object has a reference to the next object. So you can traverse with dot notation the reference to the second object, and that object has also a reference to the next object. So it's a way that you can chain those objects together how do you call let me check. How do you say this? A necklace. Yeah, it's like a necklace. I'm sorry. Today I think that my English is going somewhere else. So you can chain those objects together like in a necklace, because every object has a reference to the next element. So if you have a reference to one object, you can always say, okay, I can inspect this object, and then I can just do object.next to get to the second object, to the next object, and inspect that object too. The problem with this is that you cannot have, well, in this case, you don't have a reference to the previous object. But you can create an object that has two references, one to the next one and one to the previous one. And this would be a double-sided linked list. It's called linked list because every object in this list has a reference to some object. It links to some other object. And it's not really an array. So this is an array, and that's fine. But if you want to create a linked list, you don't need an array. You just need a structure like this one. At least this is in JavaScript. In JavaScript, you can create a list as being an object, and the object has a value, and it has a reference to the next object. And the next object is an object which contains another value, and it has a reference to the next object. So as you can see in JavaScript, linked lists look more like tree-like data structures. This does not seem like a list. It seems more like a tree in which I start with the first element, and then I have a reference to the next element. This seems pretty strange to see. In fact, another way to pose it is instead to flatten everything. And this is the way we usually create linked lists in every language. We don't create this tree-like structure. We do something like this. We start by defining the list as an object, okay? And then to this object, we add a property called next. And this property references the next object in the list, value 2. And then this object should have a next, and we can refer to this next as list.next.next if we really want to, but we're not forced to. And the same goes with value 3, value 4. Value 4 is the last element, so his next property will be just null, and this will tell us that we reached the end of the list. I don't want to say that this is a good way to pose the linked list. Let me show you a different way, which is exactly equivalent. Linked lists, JS. So let me close this one. Let me also increase the font size. So I can create an object. Let's call it obj1, and this is something that has a value of 1. Then I will create an obj2, which is an object that has a value of 2. And I will do the same with obj3 and obj4. So since I'm lazy today, I'm going to just copy paste and make sure that I'm changing every single thing properly and accordingly. Okay, we've got these 4 objects. Now that we've got these 4 objects, I can say that my list, let list, is the object 1. The list is just a reference to the first element of my necklace, of my chain. And then I can say that obj1.next, which is exactly like saying list.next, because list points to the same object, is equal to obj2. So I'm creating this link, this reference, from obj1 to obj2. And then I can say obj2 has a next, which is obj3. And I can say that obj3.next is obj4, so now they are chained together. And finally, I can say that obj4.next is null. And this is exactly the same thing that we saw in the tutorial. It's just probably it removes the nesting behavior. It seems everything is flat. But actually, if I now try to console log this list, I will probably see a structure like this one, because I'm not doing anything else than just creating a tree-like structure. Let's see if it works. Yep, the list is an object that has a value of 1 and it has a next, and the next has a value of 2 and a next, and the next has a value of 3 and a next. The next has a value of 4 and the next, which is null, so this was the last element in the list. So if I do list.next, I'm having a reference to the second element in the list. And if I say next again, this will be a reference to the third value in the list. And then again, next will give me the fourth value in the list. And if I do another next, this is null because I reached the end of the list. Linked lists are pretty important when you're studying algorithms and data structures. In my experience, I never needed a linked list in my entire life, in my entire career. We just don't need them. We need some structures that are similar. Maybe they are tree-like structures in which you have a reference not only to the next element, but in a tree-like structure you have one node, and the node has a reference to its children. And the children have references to their own children. And sometimes those nodes can also have a reference to their parent. So you have a back reference that allows you to go up the tree. So tree structures are usually important. The DOM, the elements in the browser, are a tree-like structure because we have the root node, which is HTML, and HTML has children, head and body body has other children, no script, div, script, another script, and another script, etc., etc. So tree-like structures usually are structures that allow you to traverse the tree and to get a reference to the children. Sometimes you even have a reference to the parent. Very rarely you have a reference to the siblings. Instead of having a reference to the siblings, you usually ask your father, hey, give me your other children. But yes, we can have those links between data structures in a tree-like structure. But linked lists, I can assure you, I never needed to use them other than passing an exam at university. Maybe I was lucky. Maybe there are some cases there outside in the real world that need linked lists. But in my experience, if I need a list, I just use an array in JavaScript because it is easy to have a reference to the next object given the current object. Linked lists are important in situations like the C language, in which you don't have the concept of a list, and if you need to have a dynamically a dynamic array that can change the number of items it can contain. So not like a C array. A C array has a fixed number of elements, but a linked list, can have any number of elements you want. You can just attach or remove any elements from this list as you wish. And in that case, in C, the linked list could be still interesting, relevant, and useful, because if you're not using a list implementation made by someone else, it's pretty easy to create a linked list in C. But in JavaScript, there's no real need for that. Sound like an overture to reversing binary trees. Yes, if you want. Trees are an important data structure that sometimes can be useful also in JavaScript, as I told you. Binary trees, oh my god, it's hot today. Binary trees are just a fancy word to say that they are trees which only have two children. Not one, not three, not zero, always two children. And if you want to really know, a heap is another data structure that is a particular case of usually a binary tree, I think. So yes, binary trees are interesting data structures, but as you can see, it is also pretty easy to implement them. If you want to create a doubly linked list, you can just have an object having also a previous reference, which I have no idea what we'll do in JavaScript. I can say that obj1.next is obj2 because the object1 has the next element which is object2. And I can also say that obj1.previous is null because the object1 doesn't have any predecessor. It's the first element in the list. While obj2 has a next which is obj3, and obj2 can have a reference to the previous element which is obj1. So you see, I'm creating a link that looks behind. And in that case, I can traverse the previous element of obj2. Instead of just going forward, I can also go back. I don't know how useful it is, and I don't know if this will destroy the interpreter. I never tried it. So this has a previous element which is obj2, and obj4.previous will be obj3. Okay, so now I created a double connection. Obj1 doesn't have any previous, but it has a next which is obj2. Obj2 has a previous which is obj1 and has a next which is obj3. And this goes until we reach obj4, which has a next which is null because it's the last element in the list, and it has a previous which is obj3. Does this work anyway? Will this create an infinite recursive structure? Okay, so the list seems to be something like, yeah, the first element has no previous value, but the next has value 3 and the previous has value 1. So now I can say list.next, which will give me 2, .next, which will give me 3, .previous, which will give me again 2, .next, so I'll give 4, then previous, which will give me 3, .previous again, which will give me 2, etc., etc. So you can see, now we created a data structure that is able to traverse next and previous. And the same goes with trees. I don't know if the tutorial talks about trees, but it's actually pretty easy. If I have these nodes here, I can, for example, say that obj1 is the root, obj2 and obj3 are direct children of obj1, and obj4 will be child of, let's say, obj3, okay? I can do this. I'm going to draw it in a comment. So I've got my obj1, and using slashes and backslashes, I'm going to mimic the structure of a tree. Obj1 has obj2 as a child, and it also has obj3 as a child. So these two are siblings. And then I can say that obj3, by using another slash, has another child, which is obj4. How can I create such a data structure? I think it's pretty easy. I can say let tree is equal to a reference to the root, obj1. And obj1 now can have an array of children. Children is a property of obj1, which I'm defining right now, which contains obj2 and obj3. And you know what? Also, obj3 has something. Obj2 has an array of children which is empty. I would still put an empty array instead of just leaving it undefined. I think it's more less error prone. So obj2 has an array of children, but it's an empty array because obj2 doesn't have any children. While obj3 instead has an array of children which contains only one element, which is obj4. Okay, so let's see what happens if I console log this tree. I'm going to paste it here. I still have the references to the objects, so this should work. And if I do tree, it's giving me... Why is it saying value next previous? Okay, no, I have to do it back again because these objects are now, let's say, dirty. They are dirtied by the fact of being part of a list. So I'm going to redefine everything from scratch. This will make things easier. Okay, so the tree, as you see, has a value. So I can just inspect the value of the root. But I can also go into the children and I can get the first child in the tree, which is obj1. In fact, it has a value 2. Or I can go to the second child, which is the one which has value 3. If I go to the first child, obj2, I can also ask its children, but the children are an empty array because obj2 has no children. And if I go to children of 1, which is the object obj3, it has children. It has one child, which is obj4. And in fact, I can have a look at the first element, and it's the object value 4, which has no children. And I should probably model it. I should say obj4.children is an empty array, just to make things less error prone. And what if I want a reference to the parent? I can. Yeah, why not? Obj1 has no parent, and I can even specify it. I can say obj1.parent is nothing. This is the root. And how do I define a root? The root is a node in the tree that has no parent. And what about obj2 and obj3? Well, obj2 has no children, but obj2 has a parent, and the parent is obj1. So I'm creating a reference from the child to the parent. And the same goes with obj3. obj3 has the same parent of obj2. So I can say that obj3 has a reference to obj1 as a parent. And what about obj4? obj4 has no children, but it has a parent. And as we said, since obj4 is described as a child of obj3, I can do this. I can say that obj4 parent is obj3. And now I created a very linked tree, because this tree is allowing me to traverse it from parents to children and also upstream like salmons. I can do tree.children.1, which is the element 3, .parent, which is again the root node, .children1 again, which is still tree. Oh, but I have to type it correctly. Then I can go to children of 0, which will give me 4. Then I go to parent, which is 3. Then I go to parent, which is 1. Then I go to children of 0, which is 2, etc., etc. So as you can see, I can do whatever I want. And you can traverse the tree up and down with by just creating those references. What is the problem in all this? The problem is that the more references you add, the more difficult it is to change the tree. This is the most difficult part. Modeling a data structure like this one is actually pretty easy. But changing the structure of your data is trickier. Let's think again about the linked list. So the linked list is, let me visualize it here too. The linked list was something like obj1, which has a reference to obj2, which has a reference to obj3, which has a reference to obj4, okay? So if I want to, let's say, remove the second object, what should I do? I should probably go to obj1 and modify the reference to the next, because the next of obj1 is not obj2 anymore, it should be obj3. And obj2 should also remove this reference from obj2 to obj3. If I don't remove this reference, what happens is that first I remove the reference from obj1 to obj2, and now obj2 references to obj3 because I want to remove obj2 from the equation. So the situation is now obj1 references obj3, which references obj4 as always, but we also have still obj2 which references obj3. We still have this situation. So this is exactly the opposite of a tree. We have obj3, which is a node that has two parents, two nodes pointing to it. And this is something that we don't want. So if we want to remove an object from a linked list, we have to make sure that we change the pointer, the reference of the previous element. So it doesn't point to the element that we want to remove, but it should point to the next element. And then we also have to remove the pointer from the element itself that we want to remove to obj3, because this way obj2 will have no references at all. It will not be referenced by anyone, and will also not reference anyone itself. So this obj2 can be safely destroyed, removed from the system. So to summarize, if I want to create a function that removes an element from a list, from a linked list, I have to pay attention to these two things. So first of all, I have to iterate somehow recursively on the list until I find the element that I want to remove. Or if I already have the reference to the element I want to remove, I don't need to iterate over the list. I already have it. The problem is, however, that it's actually pretty easy to remove the reference to the next element. I can say obj.next is now equal to null, and that's it. This takes care of removing the reference from the object that I want to remove to the next object. But it's actually pretty difficult to do this other thing. I have to find the parent of the current object, which is obj1, and change its next property. And I cannot do this in a linked list like this one because I don't have any reference to the previous element. I just have a reference to the next element. So in here I have to, unfortunately, probably iterate over all the list until I find the parent of this object. And I really encourage you to try and experiment with this. How do I, here, with just a reference to the next, how do I get a reference to the previous element, not the precious, so I can change its reference? I hope it makes sense. This is the question that I'm posing to you. While if we have a strongly linked list, if we have a linked list that is able to look at the next element and to the previous element, this task is actually easier because given the current element, I can traverse to the previous element and change its references, and I can traverse over the next element in order to change the references in here too. So with a strongly linked list, this task should be easier and should also be a little more performant, because here, without a reference to the previous element, I have to loop over the list until I find the parent of this object. Instead, with a strongly linked list, if I have a reference to the object, I can just look on the left and on the right, and that's it. But it's actually more complicated to create a strongly linked list because you have to create a link to a reference to the next and also a reference to the previous one. So there are some advantages and some drawbacks on creating different kinds of structures and different kinds of references. Think about what happens if you want to model a tree. If you want to model a tree with just a reference to the children, it's actually pretty easy to traverse the tree from parent to children. But what if you want to also go up and maybe you want to remove obj3 from the tree, well, you have to also change the reference of obj1, so it doesn't point to obj3, maybe it points to obj4 if we want to just remove this man in the middle. And in this case, having a reference to the parent would probably be a little better. So it's up to you how you design these data structures, but I don't think they are very complicated. These are not that complicated. There are more algorithms and data structures that are much more complicated than this. So yeah, this is a linked list. Oh, okay. Here you can see that they show you probably how to remove a value from the middle. And this is very similar to what I was telling you, but this is a static situation. So I've got the list with a new item that is pointing to the element 1, which is pointing to the element 2, which is pointing to the element 3, etc., etc. And if you want to remove 1 from the equation, they just say, hey, just change the reference of the first item. Instead of pointing to 1, it should point to 2, and that's it. But that's not it, because you still have this element which is pointing to 2. So you should also remove this arrow here. And I don't see a way that they tell you how to do this thing, but they are also telling you that you can enhance the link so it has also a reference to the previous element, just as I was saying. And you can also add this variable called tail, so it references the last element of the list. You can do anything you want if it's useful for your needs. And that's it for recursion, and that's it for recursive data structures. We will do tasks next Wednesday together about this. Everything's fine so far? Is this thing new to you? Or do you see it as just a more thorough way to see things that we already saw before? Just let me know in the comments, as they say on YouTube. But here we're not on YouTube. Okay, I hear silence. I don't know if the silence is due to the lagging. Okay, no feedback, going on. REST parameters and spread syntax. I would like to skip, for me both, more in-depth stuff, but also new aspects like children, parents, etc. Okay, that's cool, awesome. Yeah, this is what we were supposed. But as you can see, I didn't tell you anything about new features of the JavaScript language. These are more like new recipes, new strategies that we can adopt with the elements of syntax that we already saw together. So it's just new creative ways that you probably haven't come up with yourself, and I never came up with myself. It's just, when you read the rules of a game and then you also read the strategy book, which is built upon the rules and gives you some strategies that you never thought of. These are more like patterns. I don't want to call them patterns. We could call them idioms in this case. Bobby says, nah, everything is old, but in a new, harder to grasp concept. Of course. Okay, awesome. This is good because I wanted you guys to see these things, which are pretty complicated, but to give you a slow introduction until you are pretty much able to grasp these concepts, which are pretty hard, but you already have a solid foundation that should help you understand these things. So, REST parameters and spread syntax, I would like to skip this part because I already told you everything you need to know about the spread operator. The spread operator can be used on arrays, can be used on objects, and at a certain point, I'm pretty sure that I showed you how you can use the spread operator even on parameters of a function. And they are usually called spread REST parameters, but it's exactly the same thing. It's a spread operator. So here you can see the difference between summing two numbers and summing any number of numbers. You just spread those elements, all the Here, as you can see, all the parameters that you have in the function are spread here and are collected into an array. Args becomes an array of all the parameters that you have. And in that case, you can just iterate over the array of elements and you can perform the sum of all the elements in the array. And that's it. So you have sum all of 1, sum all of 1, 2, sum all of 1, 2, 3, which still do their job, because any parameter that you specify here will be placed in this array. And it should even work with sum all of nothing, because if you have nothing here, then probably this is an empty array. So the sum will be 0, probably. And I think we already saw this thing, right? If you want to sum all of an array, you just place the square brackets and you remove the spread operator. And this will sum all the elements in the array. But if you instead don't want to use an array and you just want to have the parameters all listed like this, you just add the 3 dots here and the parameters are spread and collected into this array of args. And that's it. You can use the spread operator even if you have some other parameter there. As just like with arrays, the spread operator should be the last element always. Should be the last parameter. But other than that, it's exactly like with arrays. You can have the first element in the array, the second element in the array, and all the rest. Here we have the first parameter of the function, the second parameter of the function, and all the other parameters. That's it. Oh yeah, the rest parameters must be at the end, which is exactly what I showed you. There is a variable called arguments, which I don't want to explain to you because this was there from the beginning of JavaScript, and I think you should never use it. Arguments was a special variable that you had inside of functions, which used to contain the array. Well, it was a collection of all the arguments that you were passing to a function, even if you don't specify those parameters in the function. You see, showName has no parameters, but in fact, you are invoking this function with parameters, and arguments was supposed to get these parameters. But the problem of arguments is that it looks like an array, but it's not an array. So you can iterate over the array of this collection of arguments. You can even get arguments of 0, arguments of 1, but there are some things that you cannot do with this argument collection. As you can see, they say it's a special array-like object, name arguments, but it's not an array. And this usually creates a lot of confusion. So since we now have the spread operator, there's no real need to use the arguments collection anymore. Just don't use it. There's also another thing that arrow functions do not even have a reference to the arguments. So why just bother using the arguments collection? Just don't use it. Spread syntax, I think we already saw this. Yeah, this is exactly what I was telling you. So let's use, for example, math.max. Math.max is a function that gets that gives you the maximum value of a series of values. As you can see, the values here are specified as a spread of all the values. So you can say max of 2 and 3, and it will give you 3, because 3 is greater than 2. But you can even pass other values here. I wrote all the numbers of the Fibonacci series up to 8. And as you can see, it will give you the maximum number. And this doesn't work with arrays. I cannot say, give me the maximum value from an array of numbers. It's just because the JavaScript language doesn't want you to use the max function like this. The max function doesn't accept only one element, which is an array. It accepts any number of elements. And that's it. This is how you use it. Internally, the math.max function is doing something like this. Max of all the numbers. Okay? That's it. Okay. So if you have an array and you want to put all these numbers into math.max, you just need to spread them. And that's it. That's the only thing you need to do. So if you have an array like let r is equal to 2, 3, 5, 1, 8, this is an array, and you want to know which is the maximum value in the array, you cannot just say math.maxr, because the max function does not accept an array, but you can spread all the elements of the array as parameters of the max function, and this will exactly lead to this situation here. Hope it makes sense. Yeah, you can spread even multiple arrays together, blah, blah, blah. All very nice looking recipes that you can look by yourselves, because I don't think it's that complicated. I would like to focus on things that are hard to grasp, and I'll try to make them easier to you. But we are going towards the end of the Academy. This is already lesson number 21, I think, which was supposed to be the last lesson, but it's not. Probably it's not. It's we're going to continue a little more because I also received some feedback about people being sad if we stop doing this Academy. So why make people sad? We're going to continue happily together until we run out of topics, probably. Okay. So, but these things you should do them by yourselves, because you have to learn to learn. You have to learn how to look at informations by yourself, try to do exercises by yourself, try to experiment with things by yourself, and maybe also try to interact more with other people. So starting from now, but maybe even starting from before, I would prefer, sorry, there's a spam call going on. I would prefer you guys to try and do these exercises and maybe share the exercises and the problems that you face together with your fellows in Discord, and with me, of course, because I'm always there. Okay, so let's not talk about this. Another thing that I already told you a lot about is this phenomenon called closure in JavaScript. Closure is very, very difficult as a concept for me, because it's one of those topics that you usually hear in interviews. They say, what is closure in JavaScript? And I usually don't have a straight answer for this. I know what closure is, but it's very, very difficult to describe. And I probably think that somewhere here there will not be a paragraph that says, closure, definition, closure is blah, blah, blah. It doesn't say it. Let's see. Maybe I'm wrong. Okay, don't see anything here, but it says, here be dragons. Nice. Blah, 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 function declarations. So what is closure? Closure. There is a general programming term, closure, that developers generally should know. Okay, yeah, they call it. There is a definition. A closure is a function that remembers its outer variables and can access them. In some languages, that's not possible, or a function should be written in a special way to make it happen. But as explained above, in JavaScript, all functions are naturally closures. There is only one exception to be covered in the new function syntax, which we don't really care about. So, what is a closure? A closure is a function that can access outer variables that are outside of its scope. And we already know this because we already said something like, let A is equal to 2. I can create a function, sum B, which is able to access a variable that is specified outside of this function. For example, return A plus B. This is valid JavaScript code. This is a function that uses an internal parameter, and it uses also an external parameter. It's not even a parameter, it's an outer variable. And this doesn't mean that you should use it. In fact, usually you should try as much as you can to create functions that only depend on their parameters and not on some external variable that can affect the behavior, the internal behavior of the function. This will probably lead to problems. But yeah, closures are something like this. Closure means that a function can provide values, can declare variables internally, and this will not be visible to the outside world, but it can use variables that are declared outside and can be used inside of the function world. And that's it. Yeah, and you also told us to keep our global scope clean, says Bobby. Exactly. There is also a paragraph about global scope. So yes, we don't want the global scope to be polluted. This was a very common term in early JavaScript. It was called global scope pollution. So pollution is very, very bad for the environment in general, but also in the JavaScript world, we don't want to have the global scope to be polluted with global variables. That's why we are leveraging this closure feature of functions to place everything inside of a function that hides, that makes those variables not accessible to the outside world. Do you recognize this kind of syntax here? This is an IIFE. This is an immediately invoked function expression, which I already told you about. It's a very clever way that we used some time ago to write some JavaScript code that will not pollute our global scope, because everything is defined into an anonymous function that as soon as it is defined, it will be invoked. So there's no variables that are leaked outside of this function. They are created, they are used, and they die inside of the scope of this function. So yeah, you already know all of this. Closure is just a fancy term for something that you already know. The count here, let count is equal to 0, is a variable that is accessible to this internal function, anonymous function. In fact, I can access it and I can even increment it. But then when I invoke make counter doesn't have any reference to the count. You cannot, make counter internally has a reference to the count, but from the outside scope, from here, you cannot say, hey, what is the value of count? Count is undefined because count was defined inside of this function called makeCounter. Look at this function in particular. This function is pretty strange because it is a function that returns a function. This is a very interesting concept that we can explore even more later on. I used to call it a higher order function because it's a function that doesn't just return a value, it's a function that returns another function that, if you call it, will return a value. So functions that return other functions are usually called higher order functions because they are not just the usual functions, they are functions that are like meta functions, right? So they are functions that return other functions. There's also another thing about garbage collection here. I know that Bobby loves to speak about garbage collection. I don't. I think that's not really that important. The only thing that I want to tell you about garbage collection is probably not even stated here, or probably yes. So yeah, I'll tell you a little bit of garbage collection, okay? How should I tell you about garbage collection? Let me just move things around. New file, garbage collection.js. So in low-level languages are the base on top of which higher-level languages are created. And those low-level languages lack some features that high-level languages do have. One of those very appreciated features is called the garbage collector. And as you can imagine, the garbage collector is someone or something that passes by, finds some garbage, collects it, and removes it from the system. In low-level languages such as C, we don't have a garbage collector. We have this concept of pointers and concepts about freeing, allocating and deallocating elements from the memory, which is a very low-level concept. You have to write some code in those languages, such as C, and this is code that allocates memory. It goes into your processor. Your processor has some memories called registers, and in those registers you can place things like in a shelf. And once you don't need those things inside of the shelf, you have to take care of removing those things one by one from the shelf. The cool thing instead about garbage collection is that there is the garbage collector which automatically goes into the shelf and say, hey, is this still used? Yes, it is. And is this still used? No, this is not used anymore. So you know what? I'm going to remove it from the shelf and just destroy it and remove it from the system. So, but the problem is, how does the garbage collector know what is used and what is not? Well, it's pretty easy actually. An object is used if there is anything that is pointing to it. It's referencing it. So for example, if I have obj1, which is an object, prop value, okay? This is a usual object. This object is an object that is being created, but at the end of the file, it will probably also be destroyed because I don't need it anymore. Nobody is calling this object. If I instead use this object inside of a function, for example, I don't know, console log of object, function print object, okay, and this function lives for some time, this object will, sorry, this is called obj1, this object will probably not be destroyed because this function is somehow referencing to this object. Okay, so the object should live because otherwise the function that is referring to this object will break. And that's how it goes. If there are other elements, other objects that have a reference to that same object, the object will stay there. But as soon as no elements refer to that object, the object can be safely destroyed and removed from the system because probably nobody will care about it and or will even reckon the loss. Let's go back to linked lists. In linked lists, if you want to remove obj2 from the linked list, you can just create a reference from obj1 to obj3, so obj2 will not even appear. But what you want to do is also to remove the reference from obj2 to obj3. You don't want this reference to be there anymore. And when you do this, then nobody is pointing to obj2. Obj2 is not pointing anymore to anybody else. So obj2 is one of those objects which will probably be garbage collected. Obj2 is not accessed by anyone, and obj2 is not referring to anyone, so it can be safely destroyed. If instead you keep this link between obj2 and obj3, maybe the garbage collector will decide to keep obj2 alive because obj2 is referring to someone that exists, so maybe obj2 should still be there. But if you keep those kind of links, you could incur into the so-called memory leaks. A memory leak happens when you should destroy elements in your system, but those elements, for some reason, and usually because they are referenced or they are referencing something else, they are kept in the system, even if you're not using them, and this bloats your memory. Not the stack. In this case, the memory is called the heap, usually. But let's just call it the memory. So, when you think that you are destroying an object, but the object is still referenced by something or is referencing something else, probably the object is actually remaining in the memory. And even if it's not to be used anymore. And if you do this multiple times, you will incur into a memory leak because there are objects in the memory that should be removed but are still there and they are bloating your memory. That's why in low-level languages such as C do not have a garbage collector, not because they are stupid, but because they want you, the developer, to have complete control on the elements that you want to keep alive and the elements that you want to remove. You never know when the garbage collector passes and removes your elements. If the garbage collector passes too late, maybe your code will bloat with some memory leaks before the garbage collector passes. Instead, in C or C++, you are the garbage collector and you are in charge of freeing the memory as soon as you see fit, which usually prevents memory leaks if you're a good developer, or will create even more memory leaks if you're a bad developer, because you're forgetting to remove these elements from the system. So in low-level languages, we have the concept of a constructor, which allows you to create new objects, but also of a destructor, which is able to free the memory from that object if the object is not needed anymore. In higher level languages instead, we've got this garbage collector, which keeps track of how many references does an object have. If the object is referenced by at least one element, this object should stay there. But as soon as the object has no references anymore, then the garbage collector at a certain point will decide to destroy that object and remove it from the system. This is garbage collection. That's it. And the cool thing is that garbage collection is part of the language. You don't even need to know that it exists. It just is there for you, and you just need to pay attention sometimes only to the fact that if you want an element to be removed from the system, you have to make sure that nobody is referencing to that element anymore. That's the only thing that you need to take care of. Okay, there is another topic here which is called the Old Var, and you already know about the Old Var. I already told you that you should always use let and const. And if you're like me, you even prefer const more than let. But you should never use var. Why is that? Because var is the old way that we used to declare variables in JavaScript. It's an old, outdated way which has very strange behaviors that usually developers that come from other languages are not able to understand, because this behavior is actually pretty strange and also pretty useless. If it was a strange behavior that has any utility, then long live var, but this behavior is not needed. So I would love JavaScript to remove any reference to the var keyword, but JavaScript cannot remove anything from the language, because JavaScript, just like many other languages out there, strive to be backward compatible. They have to work on old browsers. Old code should work on modern browsers, not the opposite. So we need to keep var, but we can still keep var away from us and just use let and const every time. Why so much hate about var? Because var has no block scope, which means that if I declare a variable inside of any block, for example an if block, var is actually visible outside of the scope of the block. If I say if true, var test is equal to true, and if I inspect what is the value of test, well, test has a value because var is declared as if it was declared outside of this block scope, which doesn't make any sense. It's not useful. Other languages do not allow you to do this. And it's actually a good thing, because if you want to have variables declared in the scope of the block, and if you don't want these variables to be accessible from outside of the block, that's the reason why you declare them inside of the block. If you want this variable to be visible outside of the block, you just declare it outside. And that's it. So having this variable not accessible from outside is actually a feature that var doesn't have. Instead, let has this feature. If I declare let test is equal to true, this test variable will not be visible outside of the if block, which is exactly what every other language does. Apart from probably Python. No, probably Python too. So it is much, much better to use let for this reason. You want to have block scope. What else? Yeah, var tolerates redeclarations. This is another bug about var. I don't know if it's a bug. Maybe it's a feature that was created by the creator of var, but nobody likes it. Just nobody likes it. If you declare a variable twice, let user, you should probably see a syntax error because user was already being declared. Instead, with var, you can redeclare a variable multiple times. But this probably means that you are doing a mistake. Maybe you didn't know at a certain point in your code that there was already a var called user, and you are accidentally redefining it, breaking your code. So the fact of not being able to declare twice the same variable is actually much better than having this ability that is usually probably going to overlook some errors that you are doing in your code. So that's another reason why we don't want to use var anymore. We want to have a syntax error if we are redeclaring the same variable twice. Var variables can be declared before you use them. So in this function, you are assigning a value to phrase, even if phrase was declared on line 6. Why is that? Because in JavaScript, variables, just like functions, are subject to this phenomenon called hoisting. The variables are hoisted up, are lifted up, so they are declared at the top of your function or of your file. And this makes a lot of confusion. Why should you ever declare a variable before you use it? Just don't do it. And let allows you to not do this kind of thing. Blah, blah, blah. So if you look at let, no, it doesn't tell you. Let should always be, a variable declared with let should always be declared before it is used, which is the proper way to declare variables. You first declare a variable and then you use it. And this is exactly the same in every other language. So that's another reason why we don't want to use var. And finally, there's also a topic here, a paragraph about the IIFE. var will pollute your global scope because it will declare a variable that will be global. That's why we needed an IIFE to prevent this variable to become part of the global scope. Now with let and const, we probably don't really need this IIFE anymore, and especially with JavaScript modules, which is something that I haven't talked about. But yeah, with modules and with let and const, you can avoid using an IIFE to prevent polluting the global scope. So that's even better. So don't use var. And that's it. So nothing really new to you here, right? We already mentioned multiple times why we don't like var anymore. We already mentioned multiple times the IIFE. So let's just go forward. Oh, global objects. There is only one thing that is new here. And the thing that is new is that I already told you that alert is a function, while, for example, math.max is a function, but we can call it a method because it's a function that belongs to the object called math. Well, I lied to you, because alert is also a method. In fact, it's a method of the window object. So it's not just a function that lives somewhere in the JavaScript world. It is a method that belongs to the window object. And even console, I think. Console, if I say window console, yeah, it is a method. Well, console is actually an object that is able to do log, for example, or error, or info, or warn, or other things. But console is actually a global variable, and every global variable is just a variable that is attached to the global scope, to the global object, which on the browser is called window, and on other environments such as Node.js has a different name. And you can find it by just saying this. If you say this here, it gives you the window. Is this exactly the window? Yes, they are a reference to the same thing. What about Node.js? Let's open Node. What if I say, do I have a window here? No, I don't, because on Node.js, well, Node.js is the JavaScript environment without the browser, without windows. So no, we don't have a window, but we have a this. And this is a strange thing here. It's a reference to an object, probably called global. Not really sure, but probably it is. Let's say global. Yeah, seems to be exactly the same. So this, is it equal to global? Yeah, apparently yes. So in Node.js, we don't have a window, but we have an object called global. And if we do console log, hello, this is console is an object that probably belongs to this global thing. Let's see, global.console. Yep, apparently console is not just an object that is dangling there as a first-class citizen. First-class citizen is actually a variable, a property of this special object that in Node is called global. Is there a global object in the window too? Nope, but I see a global this, which I never knew before. Global this seems to be exactly the window or this. We have multiple references to the same thing, which is a good thing, because if we lost all the references, probably the window would be garbage collected. No, I'm joking, but probably not. And that's it. That's the only thing that is really, really important and interesting about this global object. We have the global object. Whenever we do something like let a is equal to 2, a is just a local variable that stays in there. It's local in JavaScript, and it just dies as soon as the garbage collector decides to rip it off. We can call the garbage collector the reaper. Instead, if I do var a is equal to 2, I cannot, because there was already an a declared with let. So I'm going to redo it again. Var a is equal to 2. Now, a is not only a local variable, I think it's also attached to window. Yes, it is. So as you can see, we polluted the global scope by just using var. If we used let, we wouldn't pollute the global scope. And we can even now redeclare a, which is something that we shouldn't be able to do, but we can. So this way, we can even redeclare important things that belong to the window, which will break our code, which will break our web application or website probably, or even the browser. So what else do I want to do? Okay, so that's the reason why with var we need an IIFE, which prevents the a to be attached to the global scope. But with let, or with const b is equal to 4, you don't have this thing. Window doesn't have b. B is still local, and you don't need an IIFE to keep it local. That's it, global object. Okay, now we've got other things that are really abstract and not really that useful. Functions are not just functions. Functions, as everything, are a special kind of object. And in fact, you can even ask things to a function. For example, this function say hi is a function, but it's also an object to which you can ask the property name, and it will give you the string say hi. Okay, what do you really need that? Probably not. And you can play with this thing in multiple ways, and it's not really that important. The function has also a length, and the length is if I remember correctly, is the number of parameters that this function accepts. So f1 has only one parameter, and if you ask f1.length, it will give you 1. f2.length will give you 2, because this function has 2 parameters. The strange thing is that if you're using the spread operator, well, you don't know in advance how many other parameters you have here, so it will just say 2, because you know for sure that it has 2 parameters, 2 to n parameters. Well, the least amount is 2. And I don't really think it's important to know these things. In our daily work, we don't need to get references to properties of a function. So let's just skip it completely. Just know that a function can be used as an object and it has multiple properties. It even has methods, which is another thing that we probably don't really care about. So yeah, just read it by yourself if you want, do the tasks, but I won't spend too much effort on this. And I think this is the last thing about functions that is really not that important. Then we will see something that is much more interesting. Sometimes you want to evaluate some JavaScript code on the fly. There is an old thing which is called, it's an old function called eval. eval allows you to type any JavaScript string, any JavaScript expression inside of a string. So let's say 2 plus 3. And eval will evaluate this string, parse it as JavaScript, and return something. But as you can see, this is not applicable anymore. Uncaught eval error. I refused categorically to evaluate a string as JavaScript because unsafe eval is not an allowed source of script in the following content security policy directive. Script as RC, self, blah, blah, blah. What? Okay. So what happened here is that we have this function eval, which is able to parse any JavaScript string expression, but it is so dangerous because you can pass whatever you want. It's so dangerous, it's so prone to security attacks that there was even a slogan which was something like "evil is evil." You can find it. Okay, this one says "evil is not evil, just misunderstood." Yeah, of course. So there are many people that say that you should never use eval. Eval is evil. The eval function is the most misused feature of JavaScript. Just avoid it. And this was written by Douglas Crockford, which is not the father of JavaScript. He's the godfather of JavaScript. He's the one that created a book called The Good Parts, which is a small book that only focuses on the good parts of early JavaScript, the reason why JavaScript is a good language. And Douglas Crockford even invented the so-called JSON notation, the JavaScript object notation that we still use nowadays. So if I'm sorry, but I always forget the name of the creator of JavaScript. I always have it on the tip of my tongue, and I'm really sorry, but he's a very clever guy. He's Brendan Eich. The problem is probably that I don't know how to pronounce this. Brendan Eich. Brendan. Thank you, Brendan, for giving us JavaScript. Brendan created the JavaScript language many years ago. He's now part of the Mozilla, I think. Mozilla, don't remember. Anyway, Brendan created this language. The language was not perfect, also because he said that he created the JavaScript language in something like a week or so. So in 1 week, you cannot do anything perfect, at least if you're a human being. So yeah, JavaScript was not perfect. It has some quirks, it has some problems like var, like many things that we already saw. And at a certain point, and this is why JavaScript was also pretty hated. One of the reasons why it was hated, it's because it was buggy, it was strange. But then Douglas Crockford came to the rescue. I knew him personally once. He's a very cool guy. And he created this book, JavaScript, The Good Parts, which is probably now not that relevant anymore because it's referring to an old version of JavaScript, which is now, well, superseded by new features of the language. So it's a fun read, it's an interesting read, but it focuses on things that are part of the old JavaScript language. For example, prototypical inheritance. How do you say that? Prototypical inheritance. Okay. Prototypical inheritance is something that I'm completely going to overlook. I'm going to completely skip it because it's cool. It's a cool feature in JavaScript, but it's an old one. It was superseded by class inheritance. Angelo, if you want to create a programming language, then you need some other languages on platform, right? But then where is that language programmed? Where does this end? Oh, this is a very cool, very interesting question. So yes, you need a programming language, and before having a programming language, we just had circuits and valves and transistors. So starting from that, we were able to create the assembly language, the assembler language. And starting from assembler, we were able to create the C language. Nowadays, I think that almost every language, new language that we create, is based on the C language. More so. Not directly maybe, but ultimately it's always C language. Because assembler is way too low level. C is low level, but it has very powerful constructs that assembler doesn't have. So C is a solid base on top of which to create other languages. There are some languages that are created on top of others, which are not C. I would say that, for example, probably Kotlin as a language, which is now widely used in Android, Kotlin compiles into Java, and probably Kotlin was programmed in Java. Once you program a language in some other language, and the language works, you can even start programming the language itself in its own language. You can, for example, create an implementation of JavaScript that is implemented on top of JavaScript. This doesn't mean that you should do it, but you can. There are some languages that are now rewritten in the same language that they are describing. So yes, it's not a never-ending story. Probably the lowest level language that you are going to build your new language upon is the C language. It's a very important language, and it's still widely used. So we're saying thanks Douglas Crockford for creating the JSON standard and for letting us understand more why JavaScript is good. Because JavaScript is good, and before this book, many people thought that it was not that good. And one of the problems of JavaScript, one of the bugs that JavaScript had, is this eval function. Eval is evil, and a few years ago, you could use eval, but if you use something like ESLint, so a linter for your code, ESLint would warn you, hey, please don't use eval. Can you use anything else rather than eval? Now, apparently, this is new to me, but even the browser tells you, no, I'm refusing myself to use eval. So how can you be able still to evaluate a JavaScript expression? Well, there is a new thing that we can use in JavaScript, which is the function constructor. You can create a new function that takes any number of parameters and will evaluate this JavaScript expression. So that's it. You can, instead of doing 2 plus 3, you can say let sum is equal to a new function that given A and given B will write this code. The last parameter is always the code that is going to be evaluated. And in this case, I'm going to write return A plus B. And no, again, this doesn't even work here. Let me see if this is a problem related to the previous eval. No, still refusing. And you know why? Probably because this is just another way to do eval. New function probably internally uses eval. So again, I cannot use this construct on the browser as it is, at least not as it is. I can probably write some JavaScript code and then run it on an HTML page, and probably that JavaScript code will be able to use the new function like this, but I cannot do this. I cannot just execute the sum. I cannot even declare the new function here because it's too unsafe. It's too risky. It has security issues. And that's why I don't care too much about explaining what this does and what it's and all the things that it's able to do. Well, it's actually just this, so we don't really care about this. I used new function once because I wanted to create some sort of framework that allows the developer to write their own JavaScript on the fly. If you think about the loop thing that I showed you, this thing here seems to be using the new function because I'm writing some JavaScript code on an HTML page. The JavaScript code is just a string of text. The string of text should be evaluated by some parser, and the parser should evaluate and give me the results of this parse. But, as I understood, this is not using the new function constructor. This is using a tool called Esprima. Esprima is a JavaScript interpreter for the JavaScript language. What? Yeah, you use this library called Esprima, and you write some string of code, and Esprima is able to do multiple things like tokenizing the program, parsing the program, etc., etc. We don't really care about this. This is abstract stuff. This is high-level stuff that we don't really care. If you want users to be able to write JavaScript code and interpret it on the fly, just don't use eval, don't use new functions, use some sort of library like Esprima. But 99% of the times, you don't need such a thing. You just want to write the code yourself, not allow users of your website to write their own code, right? So this is such an advanced concept that we don't really care about it, and we can skip it. This is the interesting part. There are some very interesting functions that are related to scheduling. This is the first time that we are going to talk about asynchronous functions. I'm starting to get a little runny nose, but I'm going to continue for the next 10 minutes, and then I'm going to sneeze and probably also use a handkerchief. For now, I'm going to stay strong. So set timeout and set interval are the first kinds of asynchronous behavior that we are going to see together. And they are really, really, really interesting. So what is set timeout? Set timeout is a function, set timeout. Set timeout accepts two parameters. One is a function, a callback function, and you already know what is a callback function. This callback function will be executed at a certain point in time. What is the certain point in time? You can say 1 second from now. I want to execute the function that I'm going to describe after 1 second from now. 1 second means 1,000 milliseconds. And this is exactly what I'm going to write, because the second parameter is the number of milliseconds that you want to wait before executing the callback function. So I'm going to write a callback function with an arrow function. This does nothing for now. And then I'm going to also add 1,000, which means wait for 1 second, 1,000 milliseconds. And inside of here, I can do a console log, wake up, not a cup, wake up. Okay, so as soon as I press enter, I'm invoking this set timeout, but I won't see console log wake up immediately. I will see this console log wake up after 1 second, hopefully. 3, 2, 1, go. Okay, I received one thing strange, 122, and then after 1 second I saw wake up. Let's not think about this 122 for now. I don't care about this. But it said wake up after 1 second. Let's see a slightly more complex scenario. Same function as before, but before the set timeout, I'm going to also console log something, and I'm going to say before. And then after the set timeout, I'm going to add some new lines. So it's, oh, no, I have to do it again. You know what? I'm going to do this on a file. MG. So let's call it scheduling JS. So this is my code. And then I'm also doing some console log of before, right before it. And I'm also going to do a console log of after, right after it. Don't worry if I wrote this code too fast. Now you're able to copy the code and to reason with me about what should happen. What is the order in which I see these console logs? Ideally, I would say that I will see before, then after 1 second I would see wake up, and then immediately after I could see after. But this is not the case. This is not the case because this function is called asynchronously. And asynchronously means, this is a very cool feature about the JavaScript language, which I never saw in any other language. And it's very confusing for developers that come from other languages, but it's actually a very, very cool feature which makes JavaScript even more performant sometimes than other languages that do not have this kind of asynchronous behavior. So what happens here is that console log is fired immediately. Then set timeout is fired immediately, but set timeout just starts the timer, and the timer is placed somewhere else. It's not in the call, it's in the call stack, but it's placed somewhere else where it starts counting. And while it's counting, the control is back to us. So I do before, I schedule the set timeout, then I continue and I will see after. And then after 1 second, the callback will actually be executed and it will call back. So the order in which I see these things is before, then it will be after, oh come on, and then after 1 second, I will see wake up. Grab your brush and put a little makeup. This is what is going to happen. And why is this going to happen? It is very clear if you look at loop. So I'll use loop again because I think it makes it really, really clear. Let's save and run. And it doesn't work for some reason that I didn't understand. Okay, is everything fine? Nope, still something strange happening. Either I have an error in my code, or maybe, let me check. Let me see what happens if I now execute this code here. Okay, I see a before, I see an after, then it returns undefined for some reason, and then it says wake up after 1 second. So this is actually good. This is actually good code. Why doesn't it use it on this? I see a set timeout here that can be used. Maybe I must use set timeout instead of this button click. So if that's the case, I can just, no, but I see a set timeout here too. So why doesn't this work? Maybe he doesn't like arrow functions. I'm going to turn this thing to a common function, but I don't think that's the problem. So console log before, console log wake up after 1 second, console log after, let's try again. Okay, now I've got an error. Okay, now it's working. So it was a problem with arrow functions. Let's do it again. Let's do it again. So when I save and run, I should see the before being placed in the call stack. I should see the set timeout being also put in the call stack. And then I should see the console log after being on the call stack. In the meantime, set timeout will actually call some web APIs. So now we're starting to have a look at this part here. The web APIs will take care of scheduling this function after 1 second. And after 1 second, with this console log, this function that does the console log, will be passed to the callback queue, which is a queue. And as soon as the call stack is empty, then the callback queue will push that invocation in the call stack. This is exactly what happens. So let's find out. Before, set timeout, and set timeout starts in the background some web API thing. This is too fast, so I'm going to run again. Rerun. Before, set timeout, which goes into web API. In the meantime, it does after. And once the call stack is empty, the thing that was in the web API, which then was moved to the callback queue, is placed in the call stack, and finally it goes again. I cannot make this slower, unfortunately, but you see the anonymous function here, which is then placed to the call stack, and it does a wake up, because this is exactly what the function does. I can, instead of calling it anonymous function, I can say, I can call it timer, so we can see it being called timer. Timer, and finally, after 1 second, timer is here, and it executes console log. You have pause and resume as controls. I guess you can try them. Yes, true, but I should also. Okay, what is happening here? Okay, yeah, probably I have to be very quick. But yeah, I saw a console log before. Now I'm in the set timeout situation, so it's in the call stack. Now the call stack is empty again because the set timeout is a web API. So this is taken care of by someone else, by some web APIs, which takes care in parallel to what I'm doing in the call stack. While the timer is processing, I can still continue and I'm doing the console log after. The web APIs took care of the timer and now it's put in something called the callback queue. The queue is different from a stack, right? The stack can have elements on the top and they can be pushed and they can be popped. The callback queue instead is a queue. So it's a first in, first out. Whatever enters, it will also be the first one that leaves. And now, after the console log after, the stack is now empty. And only when the stack is empty, the callback queue will start pushing things on the stack. So here it is. The stack was empty. Now I can push the timer from the callback queue into the call stack. The timer internally does a console log wake up, which is another call that is placed inside of the stack. And then the console log is consumed. And then finally the timer is consumed. So now everything is empty. This is what happens. This is the asynchronous behavior of JavaScript. The asynchronous behavior of JavaScript means that we have one call stack and sometimes we can perform some asynchronous operations, which we know when they start, when we know when we invoke those asynchronous operations, but we don't know when they are scheduled and when they are executed exactly. They will be executed when the call stack is empty, as soon as the call stack is empty. But let's go. Is this how the alarm clock on your phone is working? So it waits until the set time to execute the alarm, or is it done by checking if the current time is equal to the set alarm time? That's another very good question. I will probably answer to you after the coffee break if it's fine for you. Okay. So let's do 5 minutes coffee break for now. 12:01 now. So 12:06. Let's put an alarm. Bye. See you later. a few moments later. Back again. Hi. I hope you had a good coffee. And now we're back to business. So we left with Angelo posing a very interesting question. Is this how the alarm clock on your phone is working? So it waits until the set time to execute the alarm? Or is it done by checking if the current time is equal to the set alarm time? Well, the answer to this question is I don't know. I don't know how the alarm clock in my Android phone works. I know for sure that every computer, every piece of hardware, modern hardware, computers, phones, even Tamagotchis have an internal digital clock. So one of the main things that a computer can do is to tell the time, because they have a small, very small battery next to the processor, if I remember correctly. It's the BIOS battery, which takes track of the time. It's a very, very important feature of any kind of computer or device. And in that case, I don't know if on the operating system level, there are maybe some listeners that are interested to the current time and will be notified somehow of some time being the time that you set. I don't actually really know how it works. On JavaScript, you can do something like what we've done. So you can have a timer that spawns in, in 5 seconds, and that's it. So you don't need to know what is the current time. You can do it like this. I don't know if there are clocks or stopwatches in the Android system that behave like this. I also know that Android is using mainly the Java language for its applications. Yes, you can have Scala, Kotlin, or other languages which usually, however, compile into Java. If the application is made with Flutter does not compile into Java. It probably compiles into plain C, C++ code. Sometimes there are people that probably are developing applications even on the lower level, so C++ or C. I don't know how the clock application is implemented in Android, so I'm pretty sure it's not implemented in JavaScript. So probably the clock implementation that we have is not using set timeout, because set timeout, this asynchronous behavior, is only available in JavaScript. In other languages such as Java, you have another concept which is called a thread. A thread is some sort of a child spawning from the current application, from the current current process. We call it process, and process is just the application, the instance of the application that is currently running. So a thread is some sort of appendage of the process. It's a child of the process that has limited visibility on what the process is able to do and is able to perform some task independently. In JavaScript, we don't have this concept of threads because JavaScript is threadless and event-driven, which means that we cannot spawn threads in JavaScript. We can just declare callback functions that will be invoked somewhere in the web APIs. Internally, I think that web APIs are using threads. So there are threads, but we don't have control over those threads, which is a cool feature actually, because JavaScript makes asynchronous behavior very, very easy since we don't need to deal with threads. Just like we don't need to deal with garbage collection because JavaScript does it by itself, we don't need to think about threads because JavaScript takes care of threads by itself. This is true now, but I already saw people complaining about the lack of threads in JavaScript. So I think that the next generation of Node.js, which is called Dino, which is the opposite of Node, I think this will also feature threads. Not really sure about this. I love the dinosaurs. But yeah, probably this will also make it possible to create threads. Not really sure. Nope. Okay, I don't see them. But yeah, probably this will be multi-threaded. I know for sure that there are some other runtime environments or servers like Vertex, which are able to create multi-threaded, event-driven, and also multi-threaded environments. But this goes way lower level than what I want. So yes, there is a way to, let's say, create some sort of listener that will wake up at a certain point, like in this case. There's also another thing that you can do, which is very easy, and it's called polling. And polling means that you create a function that just loops over and over, and just like an annoying kid during a road trip will ask, "Hey dad, have we arrived yet? Hey, we arrived yet? What about now? What about now?" And then at a certain point the dad will say, "Yes, we have arrived." Okay? So this is polling. It's not a push mechanism, it's a pull mechanism, because the client, the person that is interested in an information, like, is it 12 o'clock now, is going to ask repeatedly, every second, every minute, every hour, whatever you want to, and it's going to ask repeatedly until some condition is satisfied. On the other hand, this that I'm showing you right now is an interesting way to pose the same thing. Instead of having the client to pull this information from the system, is the system itself that, as soon as it has that information, will push it to the client. When I'm saying client server, I'm using these terms very vaguely. I'm not talking about a client server architecture. The client is generically anyone that requests an information, and the server is generically anyone that is able to provide that information. Okay, so yeah, we've got this mechanism, and this mechanism is actually pretty easy, pretty similar to another mechanism that we already saw when creating our first CRUD application. Let me go back to the to-dos code. In the to-dos code, we created something like form.addEventListener submit event function. What is this? This is the usual way in which in JavaScript we can attach a callback function that will be executed asynchronously as soon as some event occurs. For example, the form, when created, stays there as it is. But as soon as the user clicks on the submit button, or in our case it was just pressing enter on the text input, well, then the submit event is triggered, and in that case the callback function will be executed. So if you read this code is interpreted immediately, this is interpreted immediately, this is also interpreted immediately, but this function is not executed immediately. This function is deferred. This function is declared, and it stays in the callback queue, ready to be executed, to be invoked by someone, which is not ourselves. It is the system itself which will invoke the function as soon as an event occurs. In this case, the submit event on the form. So this is cool because this function does not block the execution of other things. Think about this. If we had this code which behaves the way we expected, so we do before, then we wait a second, and then after the second we see wake up, and then we see after. Well, this would be crappy code because we have to wait 1 second before being able to look at after. This would block the rendering of our application. We had to wait 1 second, and then we can again interact with the system. This is not how it works. In JavaScript instead, you can schedule this thing, and this will be scheduled completely independently. And in the meantime, you can do other things. You can render the application, you can console log after, and only when this event occurs and the event is 1 second past, then this function will again take control of the situation and will say wake up. This is really, really cool, and it makes Node.js probably even more performant than other servers that are thread oriented, because, well, I don't know if this is actually a proved point, but I saw an article a few years ago which seemed to be very convincing. I'm not really sure about that, but if it was an article that compared the performance with other kind of servers. Let's see this one. Blah, 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 blah. Yep. So what articles like this one say is that other development environments, such as PHP, for example, every time they receive a request, they create a new process, a new instance of the application. Or in multi-threaded languages such as Java, they spawn a new thread which will handle that request. Threads are very lean, and you can create as many threads as you want, and then as soon as the request was performed, you can destroy that thread. But since you can have multiple requests at the same time, instead of destroying the thread, you just want to, clean it up and recycle it and put it in a pool where it can be reused again and again and again. So there is something called thread pooling, in which you create a bunch of threads, you put them in a pool, and as soon as a new request arrives, you use that thread taken randomly from the pool, you perform the request, and then you clean up the thread and you put it back in the pool. So you don't need to create and destroy new threads every single time. You just recycle them. You create, 10, 20, 100 threads, hoping that they are sufficient. If you need more, you can create new threads on the fly, but you usually don't destroy them. So all this thing about creating threads, destroying threads, or pooling threads is some construct that will occupy your CPU. Your processor is not just performing the requests, it's also taking care of creating and pooling and destroying threads. In JavaScript, there's no such thing as a thread, and it's not a limitation, it's actually a cool addition, because in JavaScript, Node.js has only one timeline. Let's try to visualize it like just a line. It doesn't look like a straight line. Okay, I'm going to look at like this. This is a temporal line. Here we are at instance 0, t0, and then after 1 second we are at t, 1000 milliseconds. Every time you invoke a function, this function is invoked at a certain point in time. So for example, here I am doing sum of 2 and 3. And then I can do another sum of 2 and 5 this time. And these invocations are all queued in the call stack, and they are all performed one after the other in the event loop. This is an infinite loop of time in which events could occur. For example, invoking a function. But these are synchronous functions, so nothing new happens here. When instead you do a set timeout, this is an asynchronous function. It takes only the space of one fraction of time, but then set timeout somehow calls the so-called web APIs, so it performs some operations that can take some time. But in the meantime, you can do other things, like, for example, summing 3 and 4, or summing 5 and 7. And then at a certain point, these operations will actually end. And when they end, then in here, I will have the results of those operations. Okay? So the cool thing about Node.js is that any asynchronous operation goes out of the usual event loop, is handled somewhere outside, and only once this asynchronous operation ended, then the result goes back into the event loop. But in the meantime, the event loop was completely occupied by doing real business. The processor is always occupied in doing something that has value, in performing synchronous requests or spawning other asynchronous requests, instead of spawning threads and pooling threads and other things like this. Klaus Kinski 420 says, hello, one off-topic question. Which setting is better? YCBCR 444 8-bit or YCBCR 422 10-bit? I have no idea what you're talking about. You know what? I'm curious about it, and I want to see what is this. I hope it's not a gaming setup. Should I choose blah, 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 or for full color resolution? Okay, color depth. Color depth for what? What is the problem that you're trying to achieve? Do you want to play games in full digital mode, or are you programming something that needs this information? I'm sorry, but I really don't know. I don't know the answer. My TV connected to PC. Oh, okay, I see. No, sorry, no idea. But it's an interesting question, and we can talk about it after the lesson, outside of the lesson, if you join the Discord server. So I have no idea, but I can learn, and we can find together the solution. We can find together on the internet, on forums, and we can share this information together, which I think is always valuable. I'm just going to copy this thing and place it here. If you want to join the Discord server, we can talk about this and also programming, which is what we are doing here. Okay, so I don't know what's the conclusion here, but probably they're saying that JavaScript is somehow faster. Yep, they say that from their benchmarks at least, for certain scenarios, not every time, but for certain scenarios, Node.js seems to be more performant. No, probably not. Lower is better. So probably Go is better than Node, and Node is performing worse than everybody else. Okay, no, Node.js is performing pretty badly, actually. That's strange. Okay, so I saw articles that said exactly the opposite. It depends a lot on what kind of tasks are you doing. For example, if your web server is trying to do a lot of I/O operations, a lot of non-blocking operations, then usually Node.js performs better than Java. If I remember this one, but I could be wrong. Okay, thanks, says Klaus Kinski 420. I don't have Discord. Have a great weekend. No worries. Okay, sorry for that. Anyway. Hey, AR Barcelona, want to become famous? No thanks. I just want people to learn JavaScript and to find a job in this market, because I love JavaScript and I want to share my passion. So no, I don't want to become famous, and you should never use these tools that allow you to buy followers, primes, and viewers. So thanks a lot, AR Barcelona, but I'm banning you because you're a spam bot. Bye. Okay, now let's go back to business. So scheduling is a pretty cool thing. And what happens if you instead schedule, but with a timeout of 0 seconds? This is a strange situation. So if you schedule with a timeout of 0 seconds, you could probably say, okay, I'm doing the before, then since I'm waiting 0 seconds, I'm going to do the wake up, and then finally I'm going to do the after. But this is probably not the case. Let's see. Nope, it's still doing before, after, and immediately after it's going to do the wake up. Why is it so? Well, if you remember what I told you, the callback queue will hold things that should be invoked asynchronously and will put them in the call stack only when the call stack is empty. So here we have the before being performed, then we've got the set timeout being performed, which will invoke the web APIs, which will then place something in the callback queue. and then we'll do the after, and then only once the before, the set timeout, and the after are removed from the call stack, then finally the call stack is empty and the callback queue will be able to execute this function, this timer function. So let's try console log before set timeout, but it's not invoking the callback function. It's just declaring, it's just invoking set timeout using that callback function. Now the timer is there and it's placed in the callback queue and it will be ready to be executed as soon as the call stack is empty. The call stack seems to be empty, but in the meantime, we also have another thing. We have the console log after being placed. And after the console log after is performed, now the call stack is empty and the timer will be placed in there. I don't know what happened now. There's a bug in the code, I think. There's a timer here that doesn't disappear. Okay, I don't know why there's a timer here still hanging on. I think it's a bug. But I hope that you understood. Just by wrapping your function in a set timeout doesn't guarantee that this function will be invoked immediately. In fact, the invocation of this function will be deferred as soon as the whole call stack was processed. Otherwise, it won't be executed. Strange behavior. There's also another thing that we can do, set interval. If set timeout delays the execution of a function after a while, set interval instead is going to execute the same function over and over every X milliseconds. So for example, let's schedule something every second, and this something is counting. Okay, I saw your message, now I'm going to read it. Bobby, you left out one bot message. Also, why did set time... Oh, really? Oh yeah, you're right. There's also per Karl Marx 11. Karl Marx. Why should you ask me to be famous? Spam bot. Thanks a lot, Bobby. If you want, guys, you can be my moderators. I can promote you to my moderators and you can help me clean up the message, the chat. Thanks a lot, Bobby. Also, why did set timeout when called alone return a value of 122? And once you added the console logs, it's just returned the undefined from the logs? Okay, I'm going to tell you right now. I was thinking about telling you right after, but it's fine. So if I do set timeout, what I didn't tell you is that set timeout, yeah, it should also have something here. Set timeout is one of those functions that are not void. They return something. And what they return is a number, which I haven't told you yet. So why in this piece of code instead the set timeout gave me undefined? The reason is that invoking this expression will return me what is returned by set timeout, which is the only thing that happens in this expression. But if I instead execute this expression doesn't just do the console log, the set timeout, and then again the console log. Sorry, this expression doesn't just do the set timeout, it does the console log, the set timeout, and the console log. And the thing that is returned by this expression is the last return statement, is the return statement of the last expression. The last expression here is console log, and console log is a void function. It's a function that returns nothing. It returns undefined. So that's the reason why here we see undefined, because we're not doing just set timeout, we're doing all this code, and the return statement that we see here is always the return of the last expression that we have in our code. Set timeout is the only thing that we do. Now, the problem is, what is this 117? This is the mystery that will be solved now. But I'm going to solve it with set interval. Let's use set interval and see what happens, okay? So set interval is saying console log counting, and it does it every second. So it's not waiting for a timeout. It's actually executing the same function over and over again every second. it says 102, and then it says counting once, twice, thrice, 4 times, 5 times, etc., etc. And when does it stop? Can I make it stop? Yes, I can. In fact, this 102 is the ID of this interval being executed. So now I can also use another function called clear interval, and I can pass that number 102, which allows JavaScript to stop that same interval that I just started. If I say clear interval 102, you will see that counting stops at 34. So I scheduled something and now I'm able also to stop it. That's the meaning of that number. You can do the same with set timeout. Set timeout will do something, but hello, it will say hello, but it will say it not after 1 second. It will do it after 1 second times 60 seconds, which is a minute, times 60, which is 1 hour. This thing will tell me hello in 1 hour. And that's probably too much. I don't want to wait 1 hour before reading hello. So you know what? I'm going to cancel this thing. How do I cancel it? I do a clear timeout, given number 103, and this will never say hello again. Okay? So how do I know the ID beforehand? You don't. The ID is returned to you by invoking the set interval. And you can store it in a variable. So you can say const ID is equal to set interval. And this interval is going to console log counting. Okay, but I don't like to put things on one line, so I'm going to do this extra effort and try to write good code that also is indented well. Okay, so I'm doing this interval and I'm doing this every second, and then I store the ID. Once I store the ID, I can do something like, hey, but after 5 seconds, I want to stop that interval. So I can do set timeout, which after 5 seconds, 5,000, will invoke clear interval given that ID that I stored. Okay, so let's look again at this code. I'm doing a set interval to schedule a thing happening every second, every 1,000 milliseconds. And every second I'm console logging counting. But I also store the reference to the ID of this interval. This way I can use the ID in order to stop the interval whenever I want. For example, I'm stopping the interval after 5 seconds, or I can stop the interval as soon as I click the button pause, stop, or whatever you want. In this case, I'm not using buttons, I can just use a timer, and this after 5 seconds will stop the counting. Let's see if this works. Counting, 2, 3, 4, 5, and then it stopped. Okay? So now I've got two very powerful tools. One is able to defer the execution after some time, and the other is able to instead re-execute something in a specific scheduled interval. And along with set timeout and set interval, you also have clear timeout and clear interval, which will cancel this scheduled execution. You just need to store the ID of the thing that you want to cancel somewhere, like in a variable, so you can refer to that variable later on. In this case, I didn't store the ID of set timeout because I didn't care about it, but I wanted to store the ID of the interval so I would be able to stop that interval. I think that storing the ID of the interval is usually much more important than storing the ID of the timeout. As you saw, I used the 103 to clear a timeout because I thought that it would take too much to wait 1 hour before reading hello. But usually this is not the case. You just want to wait. If you really want to stop the scheduled execution, that's fine. But usually what you want is to stop something that is going endlessly. You want to stop that thing that is going endlessly, like an interval. And that's it. I really encourage you guys to go to this latentflip.com/loop application and to watch this YouTube video, which is explaining even much better than I did all this thing about the event loop. It will tell you pretty much the same things that I told you. I think this guy says it even better. So this could be one task for you guys. Go watch someone else's video. Because as you know, I'm not the best one out there. I try to be the best one out there, but there's other people that do a pretty good job, and it would be a shame to ignore those people. So whenever I find someone that is worth watching or worth reading, I'm always suggesting it to you, because I don't want you guys to rely on just me. I want you guys to rely on yourselves and your skills and to any help that you can find online. The cool thing about programming is that everything is out there for free for you to use. So just take it. Okay, timeout and interval. Blah, 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 blah. One thing that I would like to warn you about is, however, that set interval and set timeout are still relevant nowadays, but nowadays we're also using some libraries that allow you to do very complex scheduling and asynchronous behaviors. We're going to look at promises, which are now part of the JavaScript language. And we're also going to never mention something like RxJS, but there are libraries that do very strange things. Okay, decorators and forwarding, call and apply. I don't want to talk to you about this. No, not at all. This is pretty old stuff that you probably don't want to know. Here you see a piece of code that is really similar to the solution to the problem that I asked Bobby to solve. The problem was creating a factorial function, which was not only recursive, but it was also memoized. And memoized, without the R, means that it leverages some sort of caching, which is able to avoid recomputing the same value over and over again if you already computed it at least once. How do you create a memoized factorial function? We can probably try to do something. New file, memoized Factorial Js. I hope that I'm awoke enough. Let me just copy the recursive factorial here. This is the recursive factorial. We can say something like this. The recursive factorial is computing 5 times the factorial of 4 times the factorial of 3, etc., etc. So I'm going to repeat it again here. So the factorial of 5 is equal to 5 times the factorial of 4. And the factorial of 4 will be computed on and on and on and on. So, as you know, this performs the calculation 5 times 4 times 3 times 2 times 1. But what if I then, later on, also calculate the factorial of 6? If I want to calculate the factorial of 6, this is, of course, 6 times the factorial of 5, which is exactly what you know. It's 6 times 5 times 4 times, oops, I forgot a 4, times 3 times 2 times 1. But if I already executed the factorial of 5, I already have the calculated 5 times 4 times 3 times 2 times 1. Why should I recompute this multiplication again and again and again every time I want to create the factorial of some bigger number? So this is where memoization can help us. We can cache some value that we computed, and when you want to now calculate the factorial of 6, you can say, yes, the factorial of 6 is 6 times whatever was cached as the factorial of 5. If it was cached, I can use that cached value. instead of just recomputing it over and over again. That's it. This is the concept. I want to cache any calculations that are already performed for a specific number. If I already calculated the factorial of 5, then I can use that value that I've cached. If I haven't instead calculated that value before, I can calculate it and then I can put it in the cache so someone else can use the value that I stored. Okay? So in here, I can do something like create a cache. And the cache can be, for example, an object. The object contains the number that I want to store, for example, 5, and the result of that factorial, for example, 120. Of course, I don't want to hard code it here. I want to use the cache while I'm using it, right? So I'll start with an empty cache. And then in here, instead of just returning this thing immediately, I can do something like this. Let's find out if I have a cached factorial. So I can say const factorial is equal to cache of num. Because if the number was cached, then I can retrieve it with a bracket, with square bracket notation from the cache. Maybe I can find it. And if I can find it, well, probably, yeah, okay, I can just return it as it is. If the factorial is there, I can just return it as it is. But this only if there is a cache. If the factorial is there, I can say if the factorial is not null, if the factorial was cached, then I'm going to return it as it is. Otherwise, it means that the factorial was not cached and I have to calculate it like this. And before returning it, I'm going to use let this time. I will say that the factorial then is the result of this calculation. And before returning it, I want to cache it so somebody else will be able to use it. And I can say cache of num is that factorial. And then I can return the factorial itself. I was really fast in typing the code, but I hope it makes sense. I'm using a cache, which is an object, key value pair. And whenever I want to do the recursive factorial, apart from the base step, which I don't think it's really relevant in this case, I look for a ready-made solution from the cache. If I find it, then I can just return it as it is. But if I don't find it, then I'm going to do the calculation, I'm going to store the result of that calculation in the cache, and then I will be able to return the factorial. And now we can see if it works. Let me do something like recursive factorial of 5, and this should console log 120. And then I'll try to do again a console log of recursive factorial, but this time of 6. And let's see what happens. I'm going to do this on node. So Ctrl J, clear everything, and then I'm going to do a node memoized. Oh, I did put it on the homework. Wrong. Okay, this is not working because it says cache of num was accessed before initialization. So I made some mistake. And the mistake probably is that I have to put the cache here on top. Maybe. Yep. That was the problem. I had to put the cache object on top because otherwise it would invoke the memoized factorial function before having the ability to use that cache. And the results are correct. The factorial of 5 is 120 and the factorial of 6 is 720. But did it really use any cached results? This is not really clear. So just to test this thing, just to debug it, I'm going to put a console log here. Taken from cache. If we used the cache at least once, I would see taken from cache. I would also probably use a num taken from cache, so we also know which number was taken from the cache. Let's see. Okay, so we calculated the factorial of 5 and it was 120, and apparently in the process we also stored the value of that factorial in the cache. And then when we wanted to calculate the factorial of 6, then 6 factorial is 6 times the factorial of 5. But the factorial of 5 was already stored in the cache. So we took it from the cache, and this was just 6 times 120, which was already calculated. So yeah, this is a function that uses a cache. It's working. Now we are sure that it's working. But I don't like this cache being here on top. As you can see, we are even generated an error because the cache should have been declared before these console logs. This is not really that useful. This is probably very error prone. And I would actually want the cache to be part of the recursive factorial. This is where Bobby had some struggles. Now add the cache inside of the function. Yes, this is where Bobby struggled a little bit. He said, okay, I need the cache to be inside of the recursive factorial situation here. So I'm going to just move the cache inside of here. But this has a completely different meaning, because every time you invoke a recursive factorial function, this will have its own cache. So this is not working as expected. You are creating the recursive factorial function of 5, which will never see anything inside of the cache. So it will compute everything and will store that thing in the cache, but it's the cache of the number 5. And the recursive factorial of 6 will declare a new cache, which doesn't contain the value that we cached for function 5. So that's where things go wrong. I initially put the cache as a value outside of the function, and I did this on purpose because I want this cache to work for every execution of the recursive factorial. I don't want this cache to be part of this specific instance of the invocation. So the cache should be outside, should stay outside. And how do I solve this thing? Well, I can use a higher order function. I can use something that is very similar to the IIFE, or I can even use the IIFE. What I can do is to wrap all this code inside of a function. And as you can imagine, now the cache is still doing its job properly because it's outside of the recursive factorial function, but is now inside of this function, so it's not accessible from outside. What Bobby did was to create an IIFE. So it means that he wrapped this anonymous function into parentheses and immediately invoked this function. The problem here is that now recursive factorial is a function that is declared inside of this IIFE, so you don't have access to this function from outside, which means that you also need to put these console logs inside of the IIFE, which is not what we wanted actually. I would like to separate the definition of this memoized recursive factorial function outside of the scope of where I'm using these functions, I'm invoking these functions. So instead of an IIFE, I would probably use something similar, but different. I could call it memoize. This is a function called memoize, and this function can return the recursive factorial function. This is a higher order function. This is a function that returns another function. And to make it even more difficult, this function is also a recursive function. In fact, it's returning itself sometimes, it's invoking itself sometimes. But we don't care too much about that. We know that that part just works. That thing already works. The thing that we care about now is that the memoize function is a higher order function that is able to just return the function as it is. And the perk of this, the advantage of this, is that the memoize function can use a cache. I can leave that cache there. But how do I use the memoize function? Well, I can do something like this. I can declare a memoized factorial, which is the result of invoking memoize. Because memoize, what it does, it's a function that when I invoke, declares a cache and then returns a function. And this function can be stored as a variable, memoized factorial. And now I can use memoized factorial as a function. And this should just work. Bobby says, or you can just give a name to the IIFE, or should I say put it in a variable? Yes, probably. So you can give a name to the function, which is pretty much the same thing that I did, or store it in a variable, which would be just declaring a function expression instead of a function declaration. But what is also important is that you have to return this inner function so it can be used as the memoized version of that previous function. So yeah, you're there. The IIFE solution is already good enough. This memoized version is also good, and I'm explaining it to you now just because I already mentioned today the fact of higher order functions that are able to return other functions. Why should you need such a higher order function? Well, maybe, for example, because you want this memoized function to cache something. And then you're able to execute the function that uses this cache. Let's see if it works, however. Yep, the numbers are still there. I removed the console log, so I don't see 5 taken from cache. But if I re-add the console log, everything should be fine. Num taken, come on, this is a string, taken from cache. We can even say the value. The value is factorial. And let's see what it says. After calculating the factorial of 5, when calculating the factorial of 6, I see that 5 was taken from cache and its value was 120. So calculating the factorial of 6 was as easy as doing 6 times 120, the value that was already cached. And that's it. If you're smart enough, and I don't think I am, you can even create a generic memoize function. The generic memoize function could be a function that accepts a function that you want to memoize, and this function should do something like, I actually don't know. I should probably invoke this function here, something like this. I'm not really sure I'm able to now. What happens if I do something like, let me check. What if I put this here? Will this still work? Let me see if this works, if I just change the order. Yep, it still works. So here I have a situation. I just moved this part of the calculation down. So even if we have the factorial of 1 already calculated, you can take it from the cache. The factorial of 1 would be as stupid as saying, give me 1. So this is a part which is a block of code which is part of the memoization, because I'm getting values from the cache if they are there. This is part of the factorial function. This is also part of the factorial function. And this is part of the cache behavior. So I think I can try to isolate this thing as being the generic function that I want to memoize somehow. Probably. So if this is true, I can probably redeclare once again my factorial function, function factorial. And my factorial function given a number is exactly what we already know. It's this thing here. If the number is 1, then return the number itself. Otherwise, return the number multiplied by the factorial of number minus 1. So this is again the ordinary factorial function, not memoized. But now we are creating a higher order function that takes any function from outside. And well, the thing that we're going to try is to use this factorial function here. But whatever is the factorial function, we can probably turn all this code, which is now placed inside of its own function, we can turn it into something like, hey, you know the results? Well, you know the factorial? The factorial is the result of invoking the function on the number. And to make it even more generic, this is not even the factorial anymore, because this is a generic function. So this could be a result, any generic results. So let me get back to your messages. I'm sorry, I ignored you. So Bobby says, it makes me sad that it took you 5 minutes to make it even while explaining it in the last days. Well, of course, that's why I'm here. Don't worry, you shouldn't be sad. I spent not days, probably even weeks understanding these things the first time. I'm more experienced. I'm not smarter than you. I just have more experience. You just have to gain more experience. Angela says, I got an error message posted on Discord. Yep, so I'm going immediately to Discord and see what is the error message. Memoized factorial is not a function. So I see here, can I make it bigger? Open original. Okay, I make it bigger. So const memoized factorial is equal to memoize. And memoize is this function that you have here. And then you have let cache, recursive factorial num, factorial cache, everything seems fine. And then it says memoized factorial is not a function. You know what? Memoize is declaring a cache. It's declaring the function, but it's not returning that function. This is the problem that you have here. The only thing that's missing is return that function. This should work. Function like memoize is a higher order function because it's a function that doesn't just return a value, it's a function that returns a function. So yeah, you cannot just declare an internal function, you also have to return it from the memoize function. Let me know if this works. I'm pretty confident that it does. And while you are fixing this, I would like to go back. I'm going back because I'm afraid that I went too fast in here and I don't want you guys to miss important parts. So you should have something like this. The function memoize returns the function. Words, thanks a lot. Okay, starting from here, we can try even to make the memoize function a generic function that takes any kind of function and is able to memoize it. How is it possible? Well, we have to do some sort of pre-refactoring first. For example, we can move this if right after the part in which we look for the cache, because this just works. There's no difference here. The only difference is that if we are calculating the factorial of 1, the factorial of 1 will also be retrieved from the cache, which is kind of stupid because it's a very trivial calculation. The factorial of 1 is 1, but still, it works. We can retrieve the factorial of 1 from the cache. Otherwise, if the number is 1, we return num, or we calculate the factorial. Now that we move these things around, this block of code is exactly the block of code that we had before even trying to create the factorial function memoized. So you know what? I'm going to take all this code here and I'm going to redefine the factorial function. I'm not going to call it recursive factorial. I'm just going to call it factorial. The factorial function says if the number is 1, just return the number itself. Otherwise, return the number multiplied by the factorial of number minus 1. This is exactly the definition that we had before. If we want to make it even more concise, this is an if-else situation, so go with the ternary operator if you want to. We can say return num is equal to 1, then return num. Otherwise, return the number itself times the factorial of num minus 1. And this is our recursive factorial function. So it's just another way to pose it, and I'm doing this just to waste some time. Nothing more than that. Okay, now that we've got the factorial function, I know that this bit can be transformed into an invocation to that factorial function. I can say, the problem is that I have a clash in names. Oh, okay, you know what? I'm going to rename this factorial variable into just results. Every time I look for the factorial, I want it to be the result. So let me read back this thing. The recursive factorial that we have here says, I get the result from the cache. Hello, living legend, says Lumjacker. Hi! You changed name, if it's still you. Anyways, glad to see you back. So let result, I'm getting the result from the cache, if there is one. If there is one, I'm returning the result as it is. Otherwise, I'm performing some operations that are related to the factorial function, and then I'm storing the result that I find in the cache, and I'm returning the result as it is. So this bit of code can be now replaced with the invocation of the factorial function that I declared here, because I just copied, pasted, and refactored my code, but it has exactly the same meaning. So here I can say result is equal to factorial of num, because, well, I just replaced whatever is the block of code that I had before with the invocation of this factorial function. This function here is called recursive factorial, but probably this is not that important anymore. I can just leave it as an anonymous function because I'm not calling that function anymore. I'm just using the factorial itself. I don't know if this works. Let me try. Yep, still works. My small refactorings, step by step, are just changing the code so it behaves exactly the same as before, but it has some different features, different vibes. And this is what refactoring is about. Refactoring is an important step in the process of developing software that many, even experienced developers, overlook, but is really, really, really important. Many developers don't do refactoring, and that's why their code becomes a monster. Their code becomes a werewolf. And this is actually it's a concept that we teach in software engineering. When software becomes a werewolf. Oh, come on. The software werewolf. Software is like a werewolf. It looks normal until the moon comes out and it turns into a monster. Missed deadlines, blown budgets, buggy software. Everyone wants the silver bullet to kill the monster. But there's no silver bullet to kill that monster. The only thing that you can do is to tame that monster. And how do you tame it? By refactoring. Because when you refactor, you create some code that is equal in functionality to the previous code, but you are lowering the complexity. You are increasing the readability, you are increasing the flexibility, you are increasing the simplicity of this code, and you are taming the monster. So this code apparently works, and the only thing that's left to do is, you know what, instead of just calling factorial, I can call whatever function I'm passing to the memoize function. So here I can invoke that function, whatever function it is, and now if we memoize the factorial function, we have a function called memoize which can take any function and is able to cache its results. So you can, for example, create the power function that I was asking you a while ago, and you can pass it to the memoize function. So memoize of power will be able to memoize, so cache the results of the power function. Does it work? Yep, apparently yes. So as you can see, now we are able to memoize any kind of function by leveraging the cache. Pretty complex as a situation. It's a pretty complex project that we are dealing with. And in fact, I can assure you that if you ask to any developer, JavaScript developer out there, please write me a memoize function that is able to accept a function and memoize it, caching the results, I'm pretty sure that that developer will struggle just like you did. The only reason why I didn't struggle right now is that I already tried it once. It's not that I'm intelligent or clever or smart, it's because at a certain point I decided to... Where's that? Ooh, factorial reference. I did my homework. And I tried to create an iterative factorial, I tried to create a recursive factorial, and I created also a memoized factorial. And finally, I came up with the same result that I showed to you right now, almost. I'm memoizing any function with a higher order function that returns an anonymous function that takes the element from the cache if it's present, otherwise it will calculate the results, it will cache it, and will return the results. So the reason why I was able to do this with you guys is that I already had some experience. I tried it myself. It didn't take days because I have some experience on this. So yeah, I almost cheated because I prepared this lesson a few weeks ago. And then I completely forgot everything, but luckily I was able to reconstruct what I had. Angelo, so this is why good developers are more expensive, because they also budget the time for refining, refactoring the code. I wouldn't say so. No, the refactoring, unfortunately, is not in the budget. And the testing is not in the budget. And this is a problem that we developers have. The client wants the software to work out of the box immediately, to be perfect. When a person comes to me, when a client comes to me and they ask me, please make me an app, implicitly they are saying, I want an app that also works. I want an app that is guaranteed to work. I want an app that is performant. I want an app that is secure. I want an app that I will be able to evolve in time. And these are all very implicit requirements that should never be implicit. When a developer doesn't take into account the simplicity of the code and the time and the effort that is performed in refactoring and testing, they say, yeah, I'll build you an app. And they will build a crappy code that works at first, but then it will start becoming a werewolf. Or it just will break in certain scenarios, or it will have some security issues, etc., etc. A good developer is instead able to write good code and also test it and also refactoring it in the same time that a bad developer would do the same. So no, you're not making, well, implicitly you can say, yes, a good developer is paid more. And that's because the good developer must also do some testing and some refactoring. But this is just included in the price. I, as a good developer, I think of myself as a good developer because many clients are really happy with my efforts. For example, the last project that I did is called React Quiz Game, and it's for an Italian company called A Little Bit. I like the name, it's very clever. And they asked me to create this kind of quiz application game in something like 10 days. A standard developer would say 10 days. In 10 days, I can just do the code. And then I have to spend some more days, and so spend some more money in testing, debugging, and refactoring, etc., etc. But in my case, I include these things in the price, but the price is pretty high because the client is paying for quality, not for the time that I spend on developing. Inexperienced or bad developers usually write code quickly, but the code is messy. and the code is bloated with errors, and over time they continue bloating the code with new features that are poorly designed and poorly implemented, and after a few months the code becomes a werewolf. In my case instead, I take some more time trying to develop the good thing from the start, and I test it thoroughly and I refactor it thoroughly, and at first I spend more time in developing. But if the project goes on, adding new features and fixing bugs will be easier and easier, and it will not take too much time to me. So this is the secret recipe for good developers. You have to waste some more time at first to design properly, to test properly, and to refactor properly. Even if the client doesn't understand this thing, the client probably after 1 week will say, hey, you didn't do anything? Well, I laid out a solid foundation. But you will see that things will get better over time. Instead, a bad developer will immediately write bad code from the start, and the client will be more than happy because they will see things that look good from the outside, but then later on the problems will stack up, and the software will turn back at you. In my particular case, I exercised a lot, I practiced a lot, so I am usually able to write good code and test it and also refactoring it in the same time a normal developer, an average developer would just do the coding. You see that I'm really, really fast at coding, and I'm trying to slow down. In fact, usually I type way faster than this, especially when I'm not in a rush. So that's the reason why clients like my work, because I deliver quality software in a very short time at a higher price. But the price that they are paying is way lower than the price of hiring an average developer, which will create a poor product, and then they will have to spend more time and more money to fix all the problems that accumulated over time. This project was, I wouldn't say perfect from the start, but it was almost perfect. And after 10 days, there were a few bugs that I solved in a few days, and then it was just good. It just works. And apart from the code, I also added another thing that I'm not showing here right now, but it's a storybook. It's a way to document and test interactively all the single components that are part of this application. And this was a huge value for the client, because the client didn't only want this app, they also wanted to be able to customize the app in the colors, in the text, in the behavior, because they wanted to resell this application for multiple clients with different needs. And what I did, at the same amount of price, I created this application, but I also put a storybook, and I created all this kind of interactive documentation and tests that were really, really golden for my client. The client was amazed by this results. And all this for, it was, I think I can tell about money. This was for 700 euros a day for 10 days of work. So I earned 7,000 euros to build this application. And it's not much. It's not even a small amount of money. It's probably the proper amount of money given the client that I had, the time that I had invested, and given the situation. My fare oscillates. My fare is not fixed. It depends a lot on the project. It depends on my role in the project. It depends on the client, etc., etc. For this particular situation, I earned $7,000 for 10 days of work. And the client is really, really happy with the results. They also said that they really like to work with me, and they will probably contact me again for other kinds of components. So, win-win. That is why I'm focusing a lot not only on explaining you code, but also explaining you how to build good code. I want you guys to mimic my behavior and try to create some sort of virtuous cycle and not be the usual self-taught developers out there that do a mess. I don't want you guys to do a mess. I want you guys to build good code. And maybe one day you will help me build good code and you will share a part of the profit, or you will build your own companies, but the companies will build a product that is a beautiful product and it's not a product that falls apart and makes the company default. The Abimania says, these are rookie numbers, you have to pump them up. Yes, I do pump them up. For multinational, for huge companies, my fare can go even to 1,200 euros a day. For small startups, it usually is 600 euros a day. But it depends a lot. It depends a lot. It depends on how much the client is willing to pay, how much is the budget. I even have a whole pricing page on my website. How much? What an indelicate question. Well, of course, our answer will be, it depends. There are lots of factors involved, including the client, the project, the working conditions, the country, and many more. We can't just throw a number and that's it. The price for an Inglorious service ranges from 0 to 2,000 euros a day. Yes, even 0, but unless you can provide something valuable in exchange, or you are in an endangered species, it will be higher than that. So, how much? Well, think about the highest fare you're able to pay. Now think about the highest fare you're willing to pay. Okay, now find the mean and then add some more. That's the price. It's not a joke, and it's actually quite reasonable if you think about it, because of multiple reasons that I say here. So, yeah, I try to give a high fare, but of course, it should not be a fixed fare. I always keep in mind the client that I have. If there is somebody that is not even able to pay, I'm not saying, hey, pay me 2,000 euros a day. In fact, this Inglorious Academy is €0 because I'm doing this for the people who don't have the ability to pay for a good programming course with a live teacher that explains things and helps you. I don't care about earning money for this. Yes, I could earn money, but I'm trying to reach people who need this kind of thing and who cannot afford it. And then it's up to you if you want to value this thing with money. For example, I have no idea what it means, but Deity last Wednesday gave me 100 bits. I don't know if this will give me money. Probably not. But I saw that he spent €1.50 to cheer me up with these bits. So that's already something for me. It has a meaning. I don't know what is the meaning, but it's still a meaning. It's meaningful for me. The site talks about the we, but there are any other Inglorious Coders? Actually not. The Inglorious Coders project started as trying to create a group, a team, or a squad of Inglorious Coders. And I started doing this with the Slack server, the Slack channel, in which there are some people involved. There were first all Italians, all people that I met while working or while doing lessons, and then I found out that for my specific needs, I don't want to really team up constantly with other people. Not for now. I usually find people that are not inglorious enough for my taste, or maybe they are inglorious enough, but they don't want to team up with me. So in the end, Inglorious Coders is just me, it's just myself, and if you look at the Who section, it's probably saying this. Yeah, current Inglorious Coders as a firm is a one-man army, which means there's only one person behind everything. It's me, Matteo Anthony, which is me. You can consider me as a freelance, but I'm planning to expand myself soon. Yeah, this was written a few years ago. I don't really plan to expand myself, not in this way. I don't know. Maybe one day this will become a software house with other developers that will work for me. Maybe we'll be associates and we will work together at the same level. Or maybe Inglorious Coders is just my way to create Inglorious Coders, which are not part of my company, but it's just people that share my same values and are able to work the way I do. And it's just a status. I would like you guys to become some other inglorious coders around the world, which doesn't mean that you have to give me money, which doesn't doesn't mean that I am your boss. It just means that you follow the so-called inglorious way, which is being all these things together. If you look at my website at the how section, you understand what I mean by the inglorious way. It's just a way of posing yourself towards the code, towards the client, towards the problem that you're facing, and towards life. And it sums up really well with this beautiful quote by St. Francis of Assisi, which I probably already mentioned during this academy. He who works with his hands is a laborer. He who works with his hands and his head is a craftsman. He who works with his hands and his head and his heart is an artist. This is what I truly believe, even in software. I think that software can be seen as art, as a creative process. And I hope that I'm transmitting this thing to you. If I'm transmitting this thing to you, then probably you can consider yourself inglorious coders. And that's fine for me. And of course, if you can share around the globe the fact that you think of yourself as inglorious coders, well, it's visibility to me. If you don't want to, that's fine. I'm still happy to do the academy for you because I'm not expecting anything in exchange. Okay, so let's go back to the code. If we look at this code, which is in this section called decorators and forwarding called apply, you will see that this is very, very, very similar to the memoize function that we just created. The only difference that I see here is, first of all, the name. It's called cache-in decorator instead of memoize. And the second difference that I see is that instead of an object, a plain object, it's using a map, which is something that I didn't want to stress too much. And as you can see, it was not really that important. In fact, we could create the memoize function even without knowing the concept of map. We just used a plain object. That's fine. So who cares about all this part? There is a thing called call or apply. And it's a method that you can invoke on functions, which will invoke that function by providing this context. But you also know that you can do this with the arrow functions, or you can do this with the bind method, and we usually don't care about invoking functions by passing a different context. It was important some years ago in early JavaScript, but now this is not important anymore. There are so many other ways you can completely avoid using this call or apply, and I never used these things again in my life, starting from ECMAScript 6 on, which is since 2015. So who cares about that? Let's just skip this part. Function binding, you already know everything about this because you know what this is, and you know that a function doesn't ensure that the this that you have is actually related to the this that you expect. And that's why we can solve this problem by creating wrappers, even with the set timeout, but I don't care about this. We can use the bind, which is another thing that we can do, but the most important thing is that we can use the, where is that? The arrow function. Where's that? They don't even, come on. It's impossible that they are not talking about the arrow function. I remember that they were talking about it, maybe in the next page. So who cares about that? Partial functions, yeah, we already probably started looking at, no, let's not look at this stuff. I think it's probably going to confuse you even more than, it's not going to benefit, it's just going to confuse you. Okay, now arrow functions revisited. So how do we ensure that the this that you expect is the this that you want? You just use arrow functions, because arrow functions have no concept of this. So when you use a this instead of an arrow function, the inner this is actually equal to the outer this, which is usually something that you want, provided that you are going to use the this keyword. I try to use the this keyword as least as possible. So who cares about this? Let's skip. Object properties configuration, I'm just going to skip this too. This is an advanced concept that allows you to restrict some properties, some behavior on the properties that you can access, read and write. This is an advanced concept that I'm never using in my life, and I don't want you guys to look at this during the academy. Let's just focus ourselves on the real meat, the things that you are going to use every single day, and then maybe we can have some more advanced concepts at the end of the main academy, okay? So don't want to go that way. The last topic that I want to talk to you about is about inheritance, but not this one. This is, again, another very obscure and old concept that we have in JavaScript, which we don't use anymore. So I'm just going to skip it, because now when you want to have inheritance, you actually use classical inheritance, which means inheritance made through classes. So finally, what is a class? I do have a stupid, this is mine. I do have a stupid meme about that. Yeah, here it is. C++ tells to C, you have no class. Because C is a low-level language, C++ is the C language, exactly the C language, but with the addition of classes. So let's see what classes are. Classes in JavaScript, especially, are just a sugar syntax for another kind of inheritance, which is called prototypical inheritance, prototypical. I don't know how to spell that. How do you pronounce that? Let's say prototypical inheritance. We can say it like this. So yeah, prototypical inheritance. Prototypical inheritance is a very special type of inheritance that I only saw in JavaScript. It's pretty difficult to use. And in the book by Douglas Crockford, JavaScript, The Good Parts, they explain what it is to use prototypical inheritance, and then they probably say something like, you know what, just better not use it. Yeah, if you want to use it, just use it, but otherwise you can use something else, like just a concept called mix-ins, which means that you can merge objects together. That's it. Classes are instead very, very important in other languages, such as Java or C#, or also C++. Everything there is class-based. And there's a misconception here, because we say that Java and C# are object-oriented languages because they allow you, through classes, to define objects. But we should say that those languages are class-oriented languages, because yes, they are object-oriented languages which create objects through the use of classes. JavaScript was born as an object-oriented language without the need of classes. But now it has classes too. So all this thing that I say is now pretty old. Object-oriented programming is a feature that almost every language has out there. Java has it, C# has it, PHP added it from version 5, I think. Python and Ruby have classes and objects. Now classes are everywhere. And what is a class? Well, a class is a concept that is very, very similar to the constructor function that we saw some lessons ago. It's just a construct that allows you to define how to build new objects of the same kind. So it goes like this. If you want to create a user, you can say let user is equal to name Anthony, age 38, which is actually true. It's me. This is the user. And if I want to create another user, and I use only object literals, I must look at this user, copy the property names, and maybe change the values. Like name is Angelo, and age is, were you 30? 31? I remember you were probably 31. 28? Come on, you're becoming younger and younger. Is Kaiser 219 the nickname of, I don't know, Keanu Reeves? Or even Tom Cruise? Okay, so, sorry, Angelo, I didn't want to say that you're older. So yeah, of course, you're exactly 10 years younger than me. Yeah, now I remember. So, Angelo is age 28, and if I want to create another object of the same kind, I have to define the name and the age. But in JavaScript, we had from the beginning of time the ability to create a constructor function like this one, function user, that given some parameters like name and age, is able to create a user with the same shape, but with different values for name and age. And in this case, we can say something like this.name is name, and this.age is age. This allows us to do something like this. Let yet another user to be new user given the name of Bobby and the age of Bobby. You were something like 30, 31, 32. Don't remember. Let's say you're 30 until proven wrong. 31. Okay, so this way, but it's 30. Okay, sorry. You consider yourself 28. I consider myself 18 probably. I'm that stupid. Stoutfella says, I had seen a video of Douglas from last year and he recommends not learning arrow function and classes, that it was added as a sugar syntax for Java developers, but I'll learn it just for learning's sake. I don't agree with Douglas Crockford if he said this. Totally disagree with him, because arrow functions are pretty neat, they are pretty useful, and I think that you should learn them not as the only way to learn functions. You should know that functions can be declared as function declarations, function expressions, and also arrow functions. And every kind of function has its own advantages and disadvantages. So I would recommend to still learn arrow functions. About classes, I could almost agree with him. In fact, I used to program in Java starting from university, and then in 2012 I discovered JavaScript and I found out that classes were not that important in JavaScript, at least. And as soon as classes were introduced in the JavaScript language, I was actually disappointed, because I liked the fact that JavaScript didn't have classes. It forced me to come up with other solutions that didn't require classes, and they were actually easier solutions. They were simpler solutions. But now we have classes, and some people prefer classes. I'm glad to see that some frameworks that I love and use every day, like React and Vue.js, do not make use of classes. React has the optional use of classes, but nowadays you can do everything with just functions. While frameworks like Angular by Google plus Microsoft still heavily rely on classes. In fact, it's like you took Java or C# and you tried to port it to JavaScript, to the JavaScript world. And this is why I really hate frameworks like Angular, because they are not JavaScript frameworks. They are Java frameworks written in a sort of JavaScript-like language. So it's like cheating. I don't like it. But it's my opinion. And luckily, it's not only my opinion, because Angular started decreasing in popularity more and more. Dre's Laker says, preach. Papa, don't preach. Am I preaching too much? Maybe I should just focus on teaching instead of preaching. Sorry. 219 says, Angelo is a postal code of my city. Oh, okay. I'd like to consider myself 28, says Bobby, but it's 30. Yeah, but we have the age that we feel, or that our bones feel. Okay, so new user is using a constructor function. No, I like that you shared the opinion about Angular with me. Oh, okay. So I will continue preaching then. But every time I'm preaching, I'm saying this is just my personal opinion. It's not only my opinion, but it's an opinion. Everything else is actually fact, possibly. Okay, I can also make mistakes while teaching, but I hope that those mistakes are bland. Okay, so we had this constructor function which allowed us to create new elements, new objects of the same kind. And if we try to use this thing here, we should see strange things happening. In fact, if I try to inspect this yet another user, this is not a plain object. Usually I see object name Bobby, but this is a user with name Bobby and age 30. And there's this hidden property proto object, which inside has a constructor which is f_username_age, which in turn has a proto, and this proto has a lot of things that only belong to objects. So we don't really care too much about them. Okay, now we've got a sugar syntax, which is called classes, where you can create different objects of the same kind, user, by defining a class called user. The class user is wrong because I cannot define a class and a constructor function with exactly the same name. So you know what? I'm going to call it person. It's the same. I'm going to call it person. And person, it behaves really the same as a function, as a constructor function. In fact, you can have in a class a special method called constructor. Constructor, given the name and the age, will allow you to do exactly the same thing that you can do with a constructor function. So you can say this.name is name and this.age is age. And the class can also have other methods because it's a definition of any object of the same kind. So if an object can have methods, you can define properties and methods also for this class, knowing that the class should be, however, instantiated, which means that you can create new objects from the class. You cannot use the class as it is. It's just a footprint with which you are able to build new objects of the same kind, of the same class, we say. So here we can say, for example, I don't know, speak, and speak will say something like console log, hi, my name is, and then this.name. As you can see, I'm using exactly the same syntax as that we already used while using plain objects. In fact, this is very similar to using plain objects. The problem is that you cannot use person.speak as it is because we don't have a person. We have the definition of a person. So instead of asking speak to the class person, we first instantiate a new person. We say const person is equal to a new person with name, let's do myself, or you know what, let's do Dreslaker. Dreslaker, can you share with us your name and your age, even fake ones? I don't want to invade your privacy, but since you're speaking with us, if you want to disclose this information, even if it's fake, I don't care about that. In the meantime, I'm going to say that your real name is Dreslaker and you are, let's say, I want to make you young, 26. Okay, so Dreslaker is 26, and this is a new object of kind of class person. And then I can ask the person to speak. Okay, so this method here, when I describe it in a class, is usually called, I'm going to put it here, an instance method. Why is it an instance method? It's a method that can be invoked by any instance of the class. You cannot invoke the method on the class itself. You have to instantiate. You can create. Instantiate means creating. You can create a new object of that class, and then that object, that instance, can be invoked a method. Okay, let's try it out. I'm going to copy the class and the instantiation of a new object given the class and also the invocation of the speak. Can you declare the const person inside the constructor? Would it then be available in the global scope? Ooh, that's an interesting question. So, can I declare the const person inside the constructor? You're talking about the constructor function here, right? So can I create a let or const person is equal to name and age, for example? And then will this be available outside of the constructor function in the global scope? I hope that you're talking about this. This is a very interesting question if it's posed like this. I don't know if I got it right. So when you create a function like create user, given the name and the age, what you can do, oh, in the class person. Okay. Oh yeah, you said in the constructor, I'm sorry. Okay, but what I'm saying is probably still relevant. If I create a function called create user, this is a function that I would call a factory function because it's a function that, like a factory, is able to construct new things. So if I do create user given name age, I can create a user and I can pass it the name and the age. Or if I want to be more explicit, I can create a new empty user and I can say user.name is equal name and then user.age is equal age, and then I can return the new user from this factory function. The factory function behaves exactly like you expect. Create user, if I invoke it, let's say create user given Anthony, let's say stout fella. Stout fella. Oh, come on. Okay, you see, I'm quick and fast at typing, but not when I'm under pressure. Age, what will be your age? I would say that you are, I don't know, 32. Okay, until proven wrong. Create user stout fella. This is returning a new object, and it's an object. It's just a plain object of name stout fella, age 32. This is a function that creates an object, returns it, and I usually call it a factory function for historical reasons. And also because there is a pattern, a design pattern called factory, which probably we will stumble upon. So I would like to already whisper in your ear some words that could be relevant later on. A constructor function is really similar. Instead of building the person, however, you already have automatically a reference to this, and this is an empty object, and then you pass this.name, this.age, and then you return this. But these two lines of code, the first one and the last one, are automatically provided to you by the constructor function. So you just need to focus on this.name and this.age. In a class, it's exactly the same thing. You can create a new person here. You can place everything you want inside of this person. So person.name is equal to name, person.age is equal to age, and then you can probably even try to return that person. Why am I returning true? But why do this in the constructor of a class? Yes, you can do this, but the constructor in a class is supposed to behave like the constructor function. You just have a reference to this, and you can attach properties and even methods to this in the constructor. And whatever you do here will be private. Let person is private until you expose it by returning it. This, instead, is not private because at the end of the constructor, it will be exposed. It's exactly what is returned to you after you invoke new person. This is the person. This is this. So, can you declare the const person inside the constructor? Yes, you can. But you shouldn't probably do it. Would it be then available in the global scope? No, because in the constructor is just a particular function that, just like constructor functions, encapsulates, hides, isolates everything that you put inside and that you do not expose with return. In the constructor function, you can create variables like, I don't know, const shouted name is equal to name.toUppercase. Okay? And then this dot name will be the shouted name. You can declare variables, but these variables will be local to the scope of the constructor. And these variables will be declared, will live, will be used, and then will die in the scope of the constructor. And shouted name will not be available outside. The only thing that's available outside is this object that is returned by the constructor, which is the current person. And now if I try to speak, I would probably see Dre's Laker be all uppercase. Hi, my name is Dre's Laker, all uppercase. Because I shouted the name in the constructor, I saved the name of Dre's Laker as the shouted version, and when I speak, I will use that shouted name. What happens to this person? Let me check what is this person. The person is an object of type person, of class person, and you see that there's no much difference between this class, this object created by the class, and the object that we created with the constructor function. In fact, there's no real difference. A class is just a sugar syntax that internally uses the constructor function, and it adds some more things that we don't even care about. So now we're able to build classes, and with classes we are able to specify, to define what every person is able to do, what properties it has, and what behavior it has. And then we can instantiate, we can build, we can construct multiple persons of that same kind. Is that all? No, not all. There's one small thing that we can add to this concept. Classes allow for inheritance. An inheritance means that you can have a base class that is able to create multiple kinds of of objects of the same class, but you can also create new classes that inherit from the base class and override, sometimes adding, sometimes changing some properties and behaviors from the same class. For example, let's say that this class has speak, but it also has a method called getAge. GetAge returns this.age. Very easy. The class person has a method getAge which returns whatever is the property age. And if I want to use it, let's use it. I'm going to copy all of this. I'm going to do it again here. Okay, now I can say person.getAge is equal to 26. Hoping that I got it right. I can also access the property itself, person.age 26. But there's a reason why we usually prefer methods instead of accessing directly through the properties when we are accessing those properties. And I'll tell you about this maybe during the next lesson, because now it's too late for that probably. So we've got the person getAge. Now I can define a new class. I'm going to be a little sexist here. I'm sorry for that. I don't want to offend anyone, but I like it as a joke. Just take it lightly. It's not a joke that I came up with myself. I find it online, and I really dig that joke. I just like it. I hope that nobody's offended. I can create a class called woman, which extends the concept of being a person, because a woman is a specific kind of person. And the woman, just because it extends person, behaves exactly like a person. But now I can override some properties and some behavior, some methods. In fact, if I now redefine getAge, I can customize what will happen when I ask for the age. And we can say, not because it's true, but because it's fun, that the woman, oh, Dre's Laker, you're 24. Okay, sorry, I'll correct it right now. Okay, you're 24. Well, a woman, whatever her age is, we can say that if the age is greater than 25, she will say 25. Otherwise, she will give you her real age. Okay? It's stupid. It's not true. But I like the joke. So please bear with me and don't get offended by this. Sao, are you still with us? Are you offended by this? If you are, I'm going to find another joke which doesn't offend the humankind. So, class woman extends person. Woman does exactly the same things as a person. Woman, for example, Sao, is able to be constructed by saying new woman, given her her name and her optional age. Of course not. Thanks, Sao, for the... Sao left the chat, lol. Yeah, so I'm going to give you a higher age. I don't want to... It's just to make things work. So I'm saying that you are 32. Sorry. Not because you're 32. So now, if you have this definition of a woman, the woman is a person. So I can say... Let's see what happens if I ask Sao to speak, for example. Sao speaks just like any human being. And what if I ask the age of Sao? Oh, she says she's 25. She's not telling me the age as a normal person would say. She's telling me the age as a woman class, as a woman object would say. I don't want to objectify women, but here we're talking about classes and objects. So even the males here are objectified, right? Add a comment, not really. Okay, yeah, I should probably do as you say. Not really. Thanks a lot for the suggestion, Drace Laker. Okay, so as you can see, inheritance is as easy as creating a class that extends another class. And this way, you can derive all the properties and all the methods from a base class and specialize, add some new methods, add some new properties, or even change the original meaning of the base class. You can even say something like this. If I remember correctly, in JavaScript, other than this, you also now have the property called super, but I'm not really sure about that. Let me check if it works. Probably I'm writing in another language. I don't remember. Let me check if this works. I just want to find it by myself. Is super Sao get age? Yeah, it works. So classes now introduce also the concept of super. And super means that you are using the method from the super class, from the class that you are extending. So that's it. Studfella says, if you have multiple classes, say a class for a woman and man, if I called this on a variable, how would I know which class it is referring to? This is a very, very interesting question. So this always refers to the how do you say that? To the most specific class, to the most specific type that you have. If there's no such property on the specific class, JavaScript will try to see on the base class if there is such a property. And if it doesn't find it, it will look for another property on the base class. For example, getAge is Sao's method because it's a method defined in woman. So I know for sure that if I ask Sao, what is this getAge? Sao will reply with this method here. If I ask someone else, do I have anybody else here? See, yeah, I've got the generic person, which is actually Drace Laker. If I ask person getAge, this is getAge coming from person. Of course, because, well, person, Drace Laker is a person. It's not a woman. It's the base class person. And what if I ask for a method that is not even there? What if I'm asking for toString? Is there a toString method? Yes, apparently there is. Why? Well, because implicitly, every class that you define, if it doesn't extend any other class, it's extending a special class that is already there, which is object, the object class. Okay? So there is a chain of inheritance in which when I'm accessing a property or a method of an object, the property or the method is being accessed from the same class that I'm in. But if the method or the property is not there, then the method or the property will be retrieved from the base class. And if there's nothing in there, I will go back even on the base of the base of the base. In fact, even Sao is able to do toString. ToString is a method that is not in woman, it's not in person, which is the base class, but it's in object, which is the base class of any other class. Hope it answered. Dre's Laker says, Inglorious coders, it would help everyone if you can show it like a flowchart diagram with the hierarchy. Yes, you're right. Probably there is a flowchart in the same documentation, which I could use. Or I can show you a similar thing in some other, in some other book or reference. Yes, maybe it's better to visualize things. And here you see the prototypical inheritance, which is what we are actually implicitly using. We are creating an object which has a prototype, and the prototype is another object. This is prototypical inheritance. The prototype is not like a class. In JavaScript, the prototype is just an object that I get inspiration from. Okay, so let's say that I'm your teacher and you have me as your prototype, because the way I teach and write code will be probably copied by you guys, which will add some of your own maybe. So you have me as your prototype, and you can also add your own style, your own things, your own behavior, your own uniqueness. But as a prototype, I am still an object. With classes, it's different because we all share the same type. We are all people, for example. And we all instantiate the thing of the fact of being people, of being a person. So there's no model from which you are inspired. There's just a abstract definition of what a person is, and you inherit that behavior, and you can also customize it if you want to. Let's see if I can find a good chart on this. I don't want to see those ones because these are all referred to prototypical inheritance. Instead, let's go directly to classes, and maybe in the part about classes they will show some documents. Not really. They are saying that a class implicitly is actually using still a prototype, a prototypical inheritance behavior, which is something that you don't care about. In fact, classes in JavaScript behave exactly the same as classes in Java or C# or PHP or whatever other language that you use that features classes. And the fact that they use prototypes internally shouldn't bother you. You can probably even not know this thing. You just need to know that they are classes. And no diagrams here. Class inheritance maybe here. Yeah, but they're still using prototypes, which I don't want. But see how they create a class called animal with a constructor in which the speed is initialized to 0 and the name is initialized to any parameter that was passed to the constructor. So yeah, the constructor is a method in the animal, is a special method that allows you to initialize the properties, either from parameters or with default values that you provide. And then the animal can define some instance methods like run and stop, which do things. For example, this will set the speed and will alert, and stop will actually put the speed to 0 and will alert. Then when you define a new animal, the animal is able to run and to stop, and it has two properties, the speed and the name. And I think that this is already too complicated because it uses the concept of prototypes, which we don't really care about. We just have an object, which is an instance of a class. That's it. When we deal with inheritance instead, for example, class rabbit, which extends animal, we can add, for example, a new method called hide, And now the rabbit is able to run because it's an animal, and also to hide because it's a rabbit. And if you want to see a diagram about this, this is what we have. We've got an object that inherits everything that is of the class rabbit, which also inherits from being an animal. And whenever you find something in the object itself, it uses the properties and the method that are in the object itself. Otherwise, it will look for any properties or method that are in the class, in its own class. Otherwise, it goes to the base class, etc., etc., etc. But oh my god, it's already 14 o'clock my time, and we should stop here. Sorry for interrupting so abruptly, but I think that we already covered enough, and I would love you guys to do exercises on these things. So, last thing that I want to give you is a sneak peek of a friend of mine. Aria! Aria! This is my girlfriend. She's Aria. Thanks a lot, Aria, for stopping by. Now she wants to play. I'm sorry, Aria. I'm getting back in a while. And with that said, I think I can leave you by using the usual motto. Okay, lesson, thank you. See you on Wednesday. Or says Luis Laker. Okay, remember, eat pasta, code faster. See you next Wednesday for the next practice session or next Saturday for the next lesson. Bye.